Welcome to the Azure Backup Security and Compliance Administration course. As an IT professional, expertise in Azure's backup management, security, and compliance features can greatly enhance your organization's resilience and reliability in today's data-driven era. This course is carefully crafted to equip you with essential skills for managing Azure backups, securing data across the Azure ecosystem, and enforcing compliance policies. Developed by experienced Azure professionals, this course balances theory and practice to ensure you acquire the practical skills necessary to tackle real-world challenges while also preparing you for the AZ-900 exam. Through an engaging mix of videos, readings, activities, quizzes, and a practice exam, you will learn to configure and implement backup solutions and set up automatic updates for operational efficiency. You'll apply patching protocols and use tools to manage updates effectively, securing your organization's data within Azure. Additionally, you'll ensure compliance, monitor resources, and implement disaster recovery solutions. Finally, you will engage in practical preparation for the AZ-900 Microsoft Azure Fundamentals exam. Now, let's explore the course content to make sure you're ready to start the course. Your journey begins with an exploration of Azure backup concepts, where you'll learn about essential backup strategies and configuring backup policies for files, folders, and virtual machines. Next, you'll focus on security and stability within Azure by setting up automatic updates and applying regular patching protocols to safeguard resources. You'll also use tools like Azure Update Management to maintain a secure cloud environment and ensure your systems are protected from vulnerabilities. In the third module, you will explore Azure compliance capabilities and policies. This includes configuring Azure policy, as well as monitoring and auditing to ensure your cloud environment meets regulatory and industry standards. Furthermore, you will learn about planning for disaster recovery and using Azure Site Recovery. The course content leads to an activity where you will apply your knowledge to design a secure and compliant Azure infrastructure that aligns with specific business needs. Then, a graded assessment will test your understanding of the full scope of Azure Backup, Security, and Compliance Administration. The final module will guide you through a comprehensive exam preparation, reinforcing key concepts covered throughout the program. This module includes a mix of review materials, practice assessments, and tips, ensuring you're fully prepared for the AZ-900 Microsoft Azure Fundamentals exam. By the end of this course, you will have a well-rounded skill set to effectively manage and safeguard data in Azure, ensuring your organization's cloud infrastructure is compliant and resilient. And you will be better prepared to take the AZ-900 Microsoft Azure Fundamentals exam, setting you on a path towards success in cloud computing. Now that you know more about the course, let's get started on building the skills needed to manage and protect data and ensure compliance within an Azure environment. In any data-driven organization, having a reliable backup strategy is like having an insurance policy for your data. It protects your business from unexpected disasters and keeps everything running smoothly. Just as you wouldn't drive a car without insurance, a company shouldn't operate without a backup plan. Backup plans are crucial for ensuring business continuity, safeguarding against data loss, and protecting the integrity of sensitive information, especially in modern cloud-based environments like Microsoft Azure. In this video, we'll explore practical techniques that companies can adopt to strengthen their backup frameworks and adapt to the business world's changing demands. By exploring real-world applications and the latest industry trends, you will gain the insights needed to enhance your data protection strategies and strengthen your organization's resilience against any potential challenges. Let's begin with the basics. When it comes to backups, most people are acquainted with the standard concepts of full, incremental, and differential backups. These concepts are the foundation of any backup strategy, but understanding their limitations and how they integrate with larger data protection strategies is crucial for scaling backup operations. For example, while a full backup is often the first step, it is impractical to run continuously due to the time and resources required, especially in a cloud environment. Incremental backups, which only save changes since the last backup, significantly reduce resource usage, but they need an efficient and well-maintained catalog to avoid data restoration issues. Differential backups sit between these two, balancing resource efficiency with restoration speed. In practice, businesses need to strike the right balance between these methods. For instance, a corporation with terabytes of data stored in Azure might schedule a full backup once a month and run incremental backups daily. This minimizes the impact on cloud storage resources and ensures that recovery times remain within acceptable limits. One popular approach for safeguarding your data is the 3-2-1 backup rule, which remains relevant even in cloud-based environments. The widely recognized 3-2-1 backup rule advocates keeping 3 copies of data on 2 different media with 1 copy stored off-site. However, applying this principle to modern, cloud-first environments like Azure requires adaptation. Traditional 2 media might refer to physical storage devices, but in the cloud, this could mean leveraging different regions or storage types within Azure. For example, Azure allows companies to use geo-redundant storage or GRS, which automatically replicates data across various geographical regions. While this satisfies the off-site copy requirement, businesses need to weigh the additional costs and potential latency in accessing these off-site backups. Companies that use Azure might take this further by adding redundancy at multiple levels. For example, a global corporation might store critical databases in locally redundant storage or LRS within a primary region while also using GRS for off-site redundancy. Meanwhile, less critical data could be backed up using Azure's Zone Redundant Storage or ZRS, which maintains backups across different availability zones within a region but doesn't incur the same costs as GRS. One of the most overlooked aspects of any backup strategy is the consistency model employed. Let's examine 2 of these types of models, application and crash consistent, a little closer. In the Azure environment, understanding the difference between application and crash consistent backups is vital for ensuring data integrity during recovery. A crash-consistent backup captures the system's state at a specific point in time, like pulling the power plug on a server and capturing the state of all the data. While this might suffice for systems where data is infrequently written, it is risky for applications like databases where in-flight transactions could be lost. In-flight transactions refer to data changes or transactions that are actively being processed or written to a database or application at the time a backup is initiated. These transactions are not yet finalized or committed, meaning they haven't been fully saved or recorded in the system. On the other hand, application-consistent backups ensure that all in-flight data is properly completed and saved to the database, guaranteeing that the backup is complete and reliable. For example, a global financial company that relies on a database system in Azure SQL would likely require application-consistent backups to ensure that any backup taken reflects the database's valid state. This guarantees that when restored, the data will reflect the true operational state at the time the backup was taken, ensuring business continuity. Azure Backup offers options to configure both types of consistency, but for mission-critical workloads, application-consistent backups should be prioritized. This is particularly important in scenarios where the recovery point objective, or RPO, is very low, meaning that any data loss could have severe consequences for business operations. Disaster recovery, or DR, is another essential concept, yet a common mistake is treating backup and DR as entirely separate entities. In reality, an effective backup strategy is essential for disaster recovery, but the two must be tightly integrated. Azure's native backup solutions can be seamlessly integrated with Azure's Site Recovery, or ASR, allowing businesses to both backup and replicate critical systems in secondary regions. For example, a company that is reliant on uninterrupted operations might integrate its Azure Backup strategy with ASR to not only backup databases, but also ensure that VMs hosting the web applications are replicated in a secondary region. In the event of a failure in the primary area, the VMs in the secondary region can take over, ensuring continuity. This reduces downtime and prevents data loss, protecting revenue streams. However, how can businesses keep up with the growing scale and complexity of corporate data environments? This is where automating backup processes becomes crucial to ensure consistency, reduce human error, and optimize resource use. Azure's automation capabilities allow businesses to set up policies for automated backups, defining when and how different types of backups should occur. Using Azure Policy, companies can create guardrails that ensure compliance with their backup strategy across all departments. For instance, a policy might enforce the provision of daily incremental backups and weekly full backups for all production databases. Furthermore, Azure Automation can be used to schedule backups at non-peak times, ensuring minimal disruption to business operations. Consider a large multinational company with offices across multiple continents. Each office runs its own set of applications and databases, all hosted within Azure. Through backup automation, the company can ensure that each location adheres to the same backup policy without requiring manual intervention. This guarantees that all data is consistently backed up across regions, reducing the risk of localized failures. Lastly, effective backup strategies require continuous monitoring and adjustment. Azure offers robust monitoring tools through Azure Monitor and Log Analytics, which can provide insights into backup job performance and alert administrators to any issues or failures. By regularly reviewing these logs, companies can proactively address any gaps in their backup strategy. Take the example of a media company that produces large video files daily. By using Azure Monitor to track the performance of their backup jobs, the IT department can spot if incremental backups are becoming too large. This indicates that the full backups may not be efficiently capturing changes. Just as the car insurance policy shields you from unexpected disasters, an effective backup strategy protects your data by ensuring it can be restored quickly and seamlessly, minimizing business disruption. It's not merely about creating copies of data. It's about having the right measures in place to guarantee reliable restoration when it matters most. By moving beyond basic definitions and exploring more advanced concepts such as consistency models, automation, and integration with disaster recovery, companies can fully leverage Azure's backup capabilities. Imagine you've just expanded your small bakery into a full-scale operation with locations across the country. Initially, tracking inventory, recipes, and sales is manageable with basic tools. But as the business grows and the stakes get higher, you'll need a reliable system to ensure nothing slips through the cracks. That's where Azure Backup comes in. It acts like a digital safety net, safeguarding your data as your business scales. You're probably aware that Azure Backup is a cloud-based service that simplifies data protection while providing security, scalability, and cost efficiency. In this video, you'll learn how Azure Backup empowers businesses to manage data across various environments, from on-premises servers to cloud-based virtual machines. You'll see how it automates backup processes, integrates with disaster recovery or DR, and helps you select the right consistency models to meet your specific needs. Let's begin by exploring what Azure Backup offers. Azure Backup integrates seamlessly with Azure's ecosystem, offering a unified solution for backing up files, virtual machines, databases, and even on-premises systems. The service enables businesses to manage their backups using a centralized portal, reducing complexity and the need for separate siloed backup tools. Azure Backup has several key components, including Azure Backup for VMs, which allows users to back up entire VMs running in Azure. Businesses can protect both Windows and Linux-based VMs, configuring automated backup schedules that ensure system states and data are consistently protected. Azure Backup also offers support to databases hosted in Azure, particularly SQL workloads. This includes application-consistent backups, ensuring that the backup consists of all committed transactions, reducing the risk of data corruption. Azure Backup doesn't just focus on cloud-native services. Using the Microsoft Azure Recovery Services, or MARS agent, businesses can back up on-premises data directly to the cloud. This is especially useful for companies that maintain a hybrid environment where they need to ensure continuity for both on-premises and cloud resources. Lastly, containers have become increasingly popular in modern application deployment. Azure supports the backup of Kubernetes workloads through Azure Backup for Azure Kubernetes Service, or AKS. This service helps businesses safeguard stateless and stateful container data. Now let's look at how this plays out in the real-world scenario. Imagine a global retail company, Retail Sync, with physical stores in various regions and a platform hosted in Azure. The platform is supported by Azure VMs, while SQL databases manage real-time inventory tracking and customer transactions. Using Azure Backup, Retail Sync schedules automated VM backups to run during off-peak hours to avoid service interruptions. SQL database backups are also automated with point-in-time restore capabilities, ensuring that any incident affecting the database can be quickly mitigated by rolling back to a specific transaction point. This minimizes downtime and protects the integrity of financial transactions, even if a data corruption issue arises. Retail Sync also uses the Mars agent to back up data from its on-premises systems, which hold vital customer and inventory information. By leveraging Azure Backup's cloud-based capabilities, Retail Sync can ensure that all customer-facing services stay operational even if a part of the infrastructure fails. Businesses with mission-critical applications, such as financial services or e-commerce platforms, often require application-consistent backups to ensure no transaction data is lost. In the case of Retail Sync, application-consistent backups are crucial for protecting SQL databases. Without this level of backup, the retailer could risk losing critical inventory updates or customer orders in the event of a failure. Now let's discuss one of Azure Backup's key advantages: its ability to scale. As businesses grow, their data needs increase exponentially. Azure Backup provides a scalable solution that automatically adjusts based on data volume, eliminating the need for businesses to invest in additional hardware or complex infrastructure. Additionally, Azure's pay-as-you-go pricing model ensures that companies only pay for the storage and resources they actually use. For example, Retail Sync initially started with a few hundred gigabytes of data. Over time, as the business expanded, so did the amount of data that needed protection. Azure Backup is easily scaled to accommodate terabytes of data without requiring any changes to the retailer's backup strategy or infrastructure. This flexibility is critical for enterprises looking to avoid the limitations of traditional on-premises backup systems, which often require significant upfront investment. Another important aspect of backup strategies is how they integrate with DR. Azure Backup works closely with Azure Site Recovery, or ASR, to provide a comprehensive DR solution. While backups ensure that data is recoverable, ASR enables replication and failover of entire systems, minimizing downtime in the event of a major incident. In the case of Retail Sync, ASR could be configured to replicate the primary system to a secondary region. If the primary system experiences downtime, ASR automatically fails over to the secondary region, ensuring that customers can continue making purchases without interruption. The seamless integration of backup and disaster recovery in Azure provides a safety net for businesses relying on high availability. Lastly, Azure Backup ensures that data protection extends beyond just recovery. Built-in encryption ensures that backup data is secure both in transit and at rest. Additionally, features like MFA and RBAC allow businesses to tightly control who can access backup data and how it is managed. For Retail Sync, compliance with industry standards such as GDPR is essential. Azure Backup enables them to meet regulatory requirements by providing immutable backups and audit logs, which ensure that data cannot be tampered with after it's backed up. This level of security is crucial for businesses that handle sensitive customer data, as it helps mitigate the risk of data breaches and ensures adherence to legal requirements. Azure Backup offers businesses a comprehensive, scalable, and secure solution for protecting their critical data, whether it's hosted on-premises, in the cloud, or across both environments. By automating backups, supporting multiple consistency models, and integrating with DR tools, Azure Backup simplifies data protection and ensures business continuity. For companies like Retail Sync, the ability to protect and restore both cloud and on-premises data is vital to guaranteeing operational resilience and safeguarding customer trust. Backup strategies are critical for any organization aiming to safeguard its data and ensure business continuity in case of disasters. Companies, especially those with complex infrastructures, face various risks that could lead to data loss, ranging from hardware failures and human error to natural disasters or cyber attacks. To mitigate these risks, businesses need robust disaster recovery plans that include various backup methods. This video will explore key strategies that companies can leverage, including full, incremental, differential, and off-site backups, all within the context of maintaining a comprehensive disaster recovery solution. First, let's examine full backups, the foundation of data protection. This kind of backup involves copying the entire data set from a system, regardless of whether the data has changed or not. This method ensures that businesses have a complete standalone backup of their data, which can be restored independently of any previous backups. Full backups are typically performed on a regular schedule, such as weekly or monthly, depending on the size and importance of the data. Though full backups are straightforward, their main disadvantage is that they consume a significant amount of storage and can take a long time to complete, especially for companies with large datasets. In practice, full backups are often combined with other backup strategies like incremental and differential backups to reduce their frequency and optimize storage use. For example, a corporate IT department might schedule a full backup once a week while using incremental or differential backups in between to capture changes. This way, in case of data loss, a complete restore can be performed using the latest full backup as the baseline. Next are incremental backups, which are designed to address the storage and time limitations of full backups by optimizing storage and speed. Instead of copying all data, incremental backups only capture the files that have changed since the last backup, whether it was a full or an incremental backup. This approach reduces the amount of data being backed up, speeding up the process and minimizing storage needs. Incorporating incremental backups into a disaster recovery plan can significantly improve operational efficiency. Consider a corporate scenario where daily incremental backups are performed after a weekly full backup. For each day in the week, only the files that have been added, modified, or deleted since the previous day's backup are copied. When it comes time to restore data, the company would use the last full backup and each incremental backup in sequence until the most recent data is restored. One drawback of incremental backup is the potential complexity involved in the recovery process. To restore the data, every incremental backup must be applied in order, which can increase recovery time. However, the storage and speed advantages make incremental backups a valuable component in a well-rounded backup strategy. Last are differential backups, which offer a middle ground between full and incremental backups. Like incremental backups, they only copy data that has changed since the last full backup. However, unlike incremental backups, differential backups do not reset with each backup. Instead, every differential backup captures all changes made since the last full backup, regardless of how many differential backups have already been made. This characteristic makes differential backups faster than full backups, but slightly slower than incremental ones. They're also simpler to restore than incremental backups because only two backups are needed for recovery: the latest full backup and the most recent differential backup. For businesses, the trade-off between storage space and restore complexity is a key factor when considering differential backups. A common strategy is to perform full backups weekly, incremental backups daily, and differential backups midweek to ensure that both storage usage and recovery times are optimized. Imagine a corporate environment where the IT department runs weekly full backups every Sunday, incremental backups from Monday to Wednesday, and a differential backup on Thursday. If data loss occurs on Friday, the IT team could restore from the Sunday full backup and the Thursday differential backup, bypassing the need to sequentially apply each incremental backup from the week. This balances speed and simplicity, ensuring quick recovery in a disaster scenario. While full incremental and differential backups offer protection against data loss, they may not safeguard against more severe events like natural disasters or cyber attacks that affect the primary data center. This is where off-site backups come into play. Off-site backups involve storing copies of data in a different physical location or in the cloud. For example, an enterprise might store its full backups at a secondary data center located in another region. Or it might use a cloud service provider like Azure or AWS to store backups in geographically distributed locations. In the event of a localized disaster, such as a fire or flood that affects the company's main data center, off-site backups ensure that the business can still recover its data and resume operations. This approach is particularly critical for organizations with strict regulatory requirements or high uptime demands. A corporate company can take advantage of cloud-based backup services to automate the process of transferring full and incremental backups to an off-site location. By using Azure Backup or similar services, companies can configure policies to automatically store backups in multiple regions, ensuring compliance with disaster recovery and business continuity planning. For a corporate IT department, a single backup method rarely provides comprehensive protection. Instead, companies should adopt a combination of full, incremental, differential, and offsite backups to build a resilient disaster recovery plan. For example, an enterprise might implement the following strategy. Weekly full backups are stored both locally and in an offsite location. Daily incremental backups are performed to minimize storage usage and time. Midweek differential backups are used to ensure quicker recovery in case of failure. And all backups are automatically replicated to an off-site cloud provider, ensuring data is protected even in the event of a regional disaster. In this scenario, the IT team can recover quickly from any level of failure, whether it's a simple human error or a large-scale disaster affecting their primary data center. A well-designed backup strategy is essential for ensuring business continuity in the face of disasters. Full backups provide a complete baseline of data, while incremental and differential backups optimize the storage and speed of the backup process. Off-site backups further ensure data protection against large-scale disasters. Corporate organizations, especially those with complex infrastructure, can utilize these backup methodologies to maintain continuous operations and meet recovery time objectives in the event of an unforeseen disaster. By carefully selecting and combining these strategies, businesses can implement a robust disaster recovery plan that aligns with their operational needs and regulatory requirements. Backup compliance and security best practices are crucial for safeguarding an organization's data while adhering to regulatory standards. A well-executed backup strategy not only ensures data availability in the event of a disaster, but also complies with various regulations like the General Data Protection Regulation, the Health Insurance Portability and Accountability Act, and the Service Organization Control 2. In this video, we will explore these compliance requirements and discuss the best practices that businesses should adopt to ensure secure backup processes, focusing on encryption, access controls, and audit trails to protect data throughout its lifecycle. Data regulations impose specific requirements for handling sensitive information, including how data backups should be managed. Failure to adhere to these regulations can result in large fines and legal repercussions. For example, GDPR mandates that businesses protect the personal data of EU citizens, requiring secure storage, processing, and transfer mechanisms. Article 32 of GDPR outlines the need for encryption and regular testing of backup systems to ensure compliance and data safety. Backups must be managed to allow personal data to be restored in a timely manner in the event of an incident. Next, HIPAA governs the protection of health information in the US, requiring healthcare organizations to implement specific administrative, physical, and technical safeguards. For backup compliance, HIPAA stipulates that all backups containing health information must be encrypted and securely stored to prevent unauthorized access or tampering. Failure to do so could result in a breach of patient data, leading to heavy fines and reputational damage. Lastly, SOC 2 is a set of standards for organizations that handle sensitive customer data. It requires strict control measures, particularly when it comes to data backups. SOC 2 compliance focuses on data availability, integrity, and confidentiality, making encryption and secure access control key elements of a backup strategy. As the regulations suggest, encryption is critical for securing backups, whether the data is in transit or at rest. By encrypting backup files, organizations ensure that sensitive information remains inaccessible to unauthorized users, even if the backup media is compromised. Data at rest encryption ensures that the data stored in backup files or storage systems is unreadable without the appropriate decryption keys. In cloud-based environments, this is typically achieved through managed encryption services, which allow organizations to encrypt data before sending it to the cloud or use cloud provider-managed encryption keys. AES 256 encryption is a standard widely regarded as secure for data at rest. On the other hand, data-in-transit encryption protects data as it moves between systems, especially when backups are transmitted over public networks. Secure transmission protocols like SSL/TLS are commonly used to encrypt backup data in transit, preventing interception by malicious actors. Another key component of compliance and security is implementing strict access controls to secure backup data. Not everyone in an organization needs access to backups, and limiting access to authorized personnel helps reduce the risk of data breaches. A well-defined access control policy ensures that backup data is only accessible to employees with the appropriate level of clearance. Role-based access control is one of the most effective ways to manage backup access. With RBAC, organizations assign roles to employees based on their responsibilities and restrict access to backup systems accordingly. For example, only IT administrators or compliance officers may have access to sensitive data backups, while regular staff may be restricted from even viewing the backup system. Additionally, multi-factor authentication adds another layer of security because users have to authenticate their identity using multiple factors, such as a password and a one-time code sent to their phone. This ensures that only authorized individuals can access the backup infrastructure, reducing the likelihood of unauthorized access. The third important component of compliance and security is audit trails, which record all activities related to backup processes. These logs provide a detailed account of actions taken on backup data, including when backups are created, modified, accessed, or deleted, and by whom. Backup audit trails help identify potential security threats or policy violations by tracking who accessed backups, when they were accessed, and what changes were made. If an unauthorized action occurs, organizations can quickly detect and respond to the incident, minimizing the risk of data loss or compromise. Regulatory compliance often requires regular audits of backup practices. GDPR, for example, mandates that organizations regularly test their backup systems to ensure that they function properly in case of an emergency. Having audit trails helps organizations demonstrate their compliance during regulatory reviews or internal audits. Best practices for backup security and compliance include adopting the 3-2-1 backup approach. This method advises maintaining 3 versions of data distributed across 2 different storage mediums, with one backup kept off-site. This strategy enhances both the accessibility and durability of backups in the event of a disaster. To meet compliance requirements and ensure that backups can be restored, businesses should schedule regular backup tests. These tests confirm the integrity and recoverability of backup data, helping organizations avoid nasty surprises during an actual disaster. And different regulations impose specific data retention requirements. For example, GDPR specifies that personal data should not be stored for longer than necessary. Organizations must align their backup retention policies with these requirements to avoid compliance issues. In summary, backup compliance and security best practices are essential for businesses that handle sensitive data. Regulations require robust encryption, strict access controls, and comprehensive audit trails to protect data backups. By following these best practices, organizations can ensure that their backups are secure and compliant, safeguarding both their operations and their reputation. By now, you've probably realized that Azure file shares are like an office filing cabinet for all your important documents and files, but without the space limitations. With Azure Files, you get 24/7 access from anywhere, offering cloud-based storage that uses familiar protocols like SMB or server message block. It's an ideal solution for businesses looking to move from traditional file servers to a more scalable cloud-based system. However, just as you wouldn't leave a real filing cabinet unlocked, you need to protect your digital files. That's why setting up backups is essential to safeguard your data from accidental deletion, corruption, or loss. In this video, we'll walk you through setting up backups for Azure file shares step by step. You'll learn how to use the Recovery Services Vault, configure backups, and monitor their health with best practices for keeping your data secure and your backup processes efficient. Let's begin with the foundation of any Azure backup strategy, the Recovery Services Vault, which acts as the storage location for all your backups. The following steps will guide you through setting up a Recovery Services Vault for Azure file share backups. Start by opening the Azure portal and in the search bar, type Recovery Services Vault. Now select Create to add a new vault. Here, you can provide a meaningful name, choose your subscription, and select an appropriate resource group. You then select the Azure region closest to where your file shares are located. This is important for minimizing latency during backup and restore operations. Now select Review plus Create at the bottom. After verifying details, click Create to set up the vault. With the Recovery Services Vault created, it's now ready to manage and store backups for your Azure file shares. This vault will also give you access to monitoring tools to track backup health and performance. Now that you have the Recovery Services Vault ready, the next step is to enable backup for your Azure file shares. This process links your file storage with the backup service. Start by navigating to your Recovery Services Vault and select the backup option from the top menu. Next, under the Where is your workload running section, select Azure. And under the What do you want to backup section, select Azure File Share. Then select the backup option. At this point, your infrastructure is ready to support Azure File Share backups. The next step is to associate specific file shares with the vault for ongoing backup. To get started, you need to backup your Azure File Share to a connected storage account. The first step is to register this storage account with the Recovery Services Vault, which is essential for protecting the files stored within it. Start in the Configure Backup section and select your storage account. Next, select the storage account from the list and click OK to register it with the vault. Once the storage account is registered, you'll be able to choose individual file shares for backup. After defining the backup policy, the next step is to select which file shares should be backed up. Azure allows you to back up specific file shares rather than the entire storage account, offering flexibility in data protection. You do this by opening the Recovery Services Vault, then go to Protected Items and select Backup Items. From there, navigate to Azure File Shares. Now select Add and select the storage account where your file shares reside. Next, choose the file shares you want to backup from the list. For example, in a corporate scenario, you might choose to backup file shares used by the finance and HR departments separately, depending on their specific data retention needs. This process ensures that your critical file shares are protected, while non-essential shares that don't require backup can be excluded, improving efficiency. Now it's time to set up backup policies to determine when backups are performed, how often they occur, and how long they're kept. With Azure Backup, you can create custom policies for each file share, enabling you to balance your retention needs with cost and storage efficiency. You start in the Recovery Services Vault section by selecting Backup Policies under Manage and selecting Add. Now choose to create a new policy specifically for Azure file shares. Next, define the backup frequency. Most businesses recommend daily backups. However, depending on the criticality of the data, some may prefer multiple backups per day. Now it's time to configure the retention policy. For example, you might want to retain daily backups for 30 days, weekly backups for 3 months, and monthly backups for a year. Select Create to configure the policy. Then associate the file share with the policy to apply it to your Azure file shares. This is especially useful in industries with long-term compliance requirements such as finance or healthcare. You can apply the backup policy that you configured earlier to these file shares. Finally, click Enable Backup to initiate the backup process. This step ensures that backups are scheduled and stored based on your business requirements, helping to protect critical data while managing storage costs. After configuring your backups, the final step is to monitor them to ensure everything is running smoothly. Azure Backup provides detailed logs and reporting for all backup operations, helping administrators stay informed. You do this by navigating to your Recovery Services Vault, selecting your vault, and going to the Backup Jobs under the Monitoring section. Here you'll see the status of all backup jobs, including success, failure, and in-progress backups. To manually trigger a backup, navigate to Backup Items and then Azure File Shares, select the file share and click Backup Now. If a file share needs to be restored, navigate to Backup Items, Azure File Shares, select the file share and click Restore Share on the right-hand side. When restoring a file share, Azure Backup provides options for restoring to the original location or a new file share, allowing you to recover data without overwriting the current version. For businesses, regular testing of the restore process is a best practice. Scheduling restore drills quarterly ensures that backups are functioning as expected and that data can be recovered efficiently during an actual disaster. Configuring backups for Azure file shares is an essential part of any business's data protection strategy. By following these steps, setting up a recovery services vault, registering storage accounts, configuring policies, and monitoring backups, you can ensure that your file shares are protected against accidental deletion, corruption, or loss. For corporate environments, Azure's scalable and flexible backup solutions provide a robust way to safeguard critical files without the complexities of traditional file servers. Backups play a vital role in ensuring data integrity and availability, especially in today's modern cloud environments. In Azure, configuring folder backups effectively is essential for organizations to safeguard their valuable data while balancing performance and cost efficiency. Consider Contoso Limited, a mid-sized company managing sensitive financial information across multiple departments. As Contoso transitions its operations to Azure, it faces the challenge of developing a folder backup system that not only protects its critical data, but also enhances system performance and controls expenses. The company aims to avoid unnecessary backups of non-essential data like temporary files or logs while maintaining its focus on critical business information. One of the initial steps Contoso should take is to establish a reliable backup system. A key approach to achieving this is by maintaining a clear and well-organized folder structure. A well-thought-out folder structure makes it easier to configure backups, locate data, and reduce redundancy in backup operations. In Contoso's case, the IT department decided to group files by department, such as finance, marketing, and sales, within Azure file shares. To further streamline the process, they implemented a tiered folder structure for each department, categorizing data into critical, sensitive, and general folders. This structure helps define the priority and frequency of backups. For instance, files in the critical category may require daily or hourly backups, while general data may only need weekly or bi-weekly backups. A clearly defined folder structure enables IT administrators to easily apply specific backup policies to different folder tiers, isolate high-priority files for more frequent backups, improving efficiency, and simplify restoration processes by making it easier to locate and recover the needed files. Azure Backup provides native tools for managing folder backups, making it easier to manage complex folder hierarchies and set differential backup policies based on the folder category. It's important to note that not all files need to be backed up. In fact, excluding certain files or directories can significantly reduce storage costs and improve backup performance. When configuring folder backups in Azure, it's essential to define precise inclusion and exclusion criteria. The IT team at Contoso identified that some non-essential directories, such as temporary files or logs that are periodically regenerated, do not require backups. While data categorized as critical or sensitive, including financial reports and client databases, were prioritized for more frequent backups to ensure data protection and minimize potential loss. Using Azure Backup's policy settings, Contoso's IT team configured exclusion filters for unnecessary files and applied retention rules to ensure that only critical data is retained for extended periods. This strategy minimizes backup times and reduces the overall storage footprint. Azure Backup also offers the flexibility to backup files based on metadata, such as file types or modification dates. Contoso leverages this feature to automatically exclude files older than 2 years from their general category folder, reducing the volume of data to be stored and improving the performance of incremental backups. Another vital consideration is backup scheduling. A well-defined schedule ensures that the most critical data is frequently backed up without overloading the system or creating unnecessary backups for less important data. For Contoso, the IT department established separate backup schedules for each folder category to ensure efficient data protection. Critical files are backed up every hour to minimize data loss and provide the highest level of protection in case of an incident. Sensitive files follow a daily backup schedule as they experience fewer changes compared to critical data but still require consistent protection. And general files are backed up weekly, which is sufficient given their low rate of modification and less critical nature. This approach allows Contoso to effectively balance data protection needs with resource optimization. Azure Backup allows you to configure these schedules flexibly, and Contoso benefits from using incremental backups. Incremental backups only store changes made since the last backup, reducing storage consumption and speeding up the backup process. Moreover, automation is key to ensuring backups happen consistently and without manual intervention. Contoso's IT team took advantage of Azure's automation features to configure backup jobs that run without human oversight. Azure Backup's built-in monitoring tools alert them of any failures or issues, providing confidence that their critical data is always protected. Determining how long backups should be retained is another crucial part of backup planning. Over time, storing too many backups can lead to unnecessary costs. On the other hand, deleting backups too soon may expose the company to risks in the event of delayed data corruption discovery. Contoso managed its backups by implementing a tiered retention policy. Critical files are retained for 6 months, with weekly full backups kept for long-term archiving. Sensitive files are retained for 3 months, with only monthly full backups stored for extended periods. And general files are retained for 1 month, with a focus on only retaining key operational data. Azure Backup supports flexible retention policies, allowing administrators to adjust retention times based on data importance and legal requirements. This flexibility lets Contoso optimize its storage costs while still meeting compliance requirements for financial data retention. Testing is a crucial part of various processes, including backup and restore operations, as it ensures data can be recovered during a crisis. At Contoso, the IT team conducts quarterly restore drills, stimulating data loss scenarios to practice restoring key files and verify the integrity of their backups. This proactive approach helps ensure that when a real need arises, they can quickly and efficiently recover data, minimizing downtime and avoiding potential data loss. Azure Backup includes a restore validation feature, which simplifies the testing process by providing comprehensive reports on the integrity of backups. This reassures Contoso's leadership that their business-critical data is secure and recoverable. By adopting a structured approach to folder backups in Azure, organizations like Contoso can ensure that their critical data remains safe and available while also optimizing for performance and cost. A well-organized folder structure, carefully defined inclusion-exclusion criteria, and tailored scheduling ensure that resources are used efficiently, reducing the load on both the system and storage capacity. The integration of retention policies and regular testing ensures that recovery processes can be swift and reliable even in the event of a failure. Azure's native tools offer flexibility and scalability for backup operations, empowering IT administrators to customize their backup strategy to meet the specific needs of their organization, just as Contoso Limited successfully did. Maintaining reliable backup configurations for file and folder data is crucial for data integrity and business continuity. For organizations like Contoso Limited, which leverage Azure for their cloud storage needs, efficient backup management can be the difference between seamless operations and disruptive data loss. In this video, you'll uncover strategies for monitoring and troubleshooting backup configurations in Azure, emphasizing practical steps to ensure data protection. Through the Contoso scenario, we'll explore how to set up alerts for backup job monitoring, review logs to diagnose issues, and address common problems that can arise. From setting alerts to notifying the IT team of failed backups, you'll discover how Contoso's approach to proactive monitoring can help maintain a solid backup strategy. Let's begin with proactive monitoring of your backup configurations, which is key to detecting and resolving potential issues before they escalate. Azure Monitor, integrated with Azure Backup, helps track metrics such as success rates, job duration, and storage consumption. Setting up Azure Monitor alerts is straightforward and customizable based on your company's needs. In the case of Contoso, they set up alerts to notify their IT team when backup jobs fail or exceed a predefined duration. These alerts are triggered based on log data provided by Azure Backup, allowing the team to act promptly before their service levels are affected. You can configure these alerts by navigating to either Azure Monitor or the Recovery Services Vault in the Azure portal for your created vault. Then, under Monitoring, select Alerts and then choose the Create Alert Rule option. In this section, Contoso's team selected metrics related to backup jobs such as backup job failed and backup job exceeded duration. Next, you can define an action group. Action groups specify what happens when an alert is triggered. Contoso sets their action group to send an email to their IT department, log the issue in a central system, and create a ticket for immediate investigation. Then, by leveraging dashboards in Azure Monitor, Contoso's IT department can visualize backup health and success rates in real time. This has significantly reduced the time between the detection of a backup issue and resolution. Alerts can also be integrated with other Azure services or third-party platforms to automate responses or escalate to higher-level support, ensuring that no alert goes unaddressed. Next, let's explore a fundamental aspect of troubleshooting backup issues: reviewing backup logs. Azure Backup generates detailed logs for each backup job, capturing the status, errors, and key performance data. Contoso Limited uses these logs to assess the performance of their backup jobs and investigate failures or incomplete backups. You can access these logs using the Azure portal, where detailed logs can be reviewed in the Azure Backup service within the Backup Reports section. This is where Contoso's team checks job histories to understand when and why a backup failed. Filters help identify patterns like frequent network issues or storage limitations. Or via PowerShell and Azure CLI, where Contoso can automate troubleshooting by using scripts to query logs across multiple storage accounts. This makes it easier to detect issues as the data footprint grows, helping with scalability as the company's data footprint increases across global offices. Lastly, Log Analytics is a feature within Azure Monitor. By exporting logs to Log Analytics, Contoso can perform advanced queries and visualize data, enabling them to review history and correlate with other events for better root cause analysis. Despite robust monitoring, backup configurations can still face occasional issues. Let's run through several backup issues that Contoso may face, including one of the most common issues Contoso faced was backup failures due to network disruptions. These failures were caused by network instability between their on-premises systems and Azure, often resulting in incomplete backups and data synchronization problems. Some steps Contoso can take to troubleshoot this are: by using Azure Network Watcher, you can monitor network latency and identify periods of network instability. When a backup failure is detected, the IT team correlates the failure time with network performance metrics. Configure Azure Backup to automatically retry failed jobs within a specific window, reducing manual intervention for transient network issues. And by adjusting data transfer settings, such as configuring throttling policies during peak hours, Contoso can minimize the impact of network congestion on their backups. Next, as Contoso scaled its operations, backup jobs began to fail due to insufficient storage space in the Azure file share. To avoid service disruptions, they implemented monitoring for storage capacity and adjusted their retention policies. For example, the IT team set up alerts to notify them when storage utilization exceeded 80%. This gave them enough time to expand the file share or clean up obsolete data. Additionally, Contoso optimized its backup retention policies to ensure that only the most critical data was retained for long durations. By reviewing usage patterns, they could delete older, redundant backups without risking compliance violations. Lastly, backup jobs can sometimes remain in a running state indefinitely. This is usually an indication of underlying infrastructure issues or timeouts during data transfer. To troubleshoot this, you can restart the Azure Backup service associated with the stuck job. Contoso's team could resolve the issue and resume backups without losing data. Additionally, an investigation of the Azure Backup job logs may reveal that certain data sets were taking too long to process due to large file sizes. To manage this, Contoso implemented data deduplication and compression, which improved the overall efficiency of the backup process. Effective monitoring and troubleshooting of file and folder backup configurations in Azure ensure data resilience and continuity for corporate environments like Contoso. By leveraging Azure's alerting, logging, and diagnostic tools, IT teams can promptly address potential issues and optimize their backup processes. Whether it's setting up proactive alerts, reviewing logs for root cause analysis, or resolving common problems such as network disruptions and storage limitations, these strategies allow organizations to maintain operational efficiency and minimize the risk of data loss. Backing up virtual machines or VMs in the cloud is crucial to an organization's data protection and disaster recovery strategy. Imagine a company like TechCorp that relies on its Azure-based virtual infrastructure. Data protection and disaster recovery are vital to ensuring uninterrupted service for TechCorp. A well-designed VM backup strategy plays a key role in safeguarding operations, controlling costs, and meeting regulatory requirements. Azure provides a range of backup solutions, each tailored to specific recovery objectives, storage efficiencies, and business needs. In this video, you'll discover how TechCorp strengthens its data protection using 3 essential Azure backup strategies: snapshot-based, incremental, and image-level backups. From using snapshots for quick restores before major updates to applying incremental backups for storage efficiency and application consistency, and finally to deploying image-level backups for complete disaster recovery of critical systems. By leveraging these techniques, you'll learn how to build a resilient backup strategy that ensures seamless continuity for your organization. Let's kick off with snapshot-based backups, which are one of the simplest and fastest ways to capture the state of a VM at a particular moment. A snapshot takes a copy of the VM's disk and saves it to Azure, which is especially useful for short-term backup scenarios, such as before deploying system updates or software patches. However, snapshots are not full backups. They do not provide application consistency, meaning that the captured data might not include in-memory processes or transactions. For example, TechCorp uses snapshot-based backups to quickly create restore points before their IT team performs major system upgrades. These snapshots allow them to roll back changes in case the upgrade results in system instability. While this approach is useful, it's not ideal for long-term data retention, and TechCorp needs to supplement it with other methods. In Azure, you can create snapshots directly from the Azure portal, and they're stored as page blobs in the storage account. Snapshots provide a fast, easy way to restore a VM to a previous state. Still, they should not be relied upon as the primary backup strategy due to limitations in long-term retention and consistency. For short-term or pre-update protection, however, they serve as an effective safeguard. Next are incremental backups, which offer an efficient method for saving only the data that has changed since the last backup. This significantly reduces the amount of storage required and minimizes backup time. Azure Backup, for instance, uses incremental backup technology to create recovery points without duplicating the entire dataset each time a backup is run. TechCorp, which handles significant amounts of customer data, including databases and logs that change frequently, found this approach to be essential. Rather than performing full backups each time, which would be costly in terms of storage and time, TechCorp relies on incremental backups. Their backup system captures only the differences between the last backup and the current state of the VM, thus optimizing storage use and reducing network traffic. With incremental backups, Azure also ensures application-consistent backups for both Windows and Linux VMs by using the Volume Shadow Copy Service, or VSS, in Windows and pre-post scripts in Linux environments. This means that VMs backed up using this method can be fully restored with data consistency at the application level, which is critical for database-heavy applications. The last approach is image-level backups. These involve creating a complete backup of a VM, including the operating system, configuration files, and data volumes. This strategy is often used when an exact replica of a VM needs to be captured and fully restored in case of catastrophic failure, or to spin up identical environments for development, testing, or migration purposes. For example, TechCorp uses image-level backups to replicate their mission-critical VMs across different Azure regions. This allows them to have a hot standby environment ready for disaster recovery purposes. Since image-level backups store the entire VM, including the OS and settings, TechCorp can confidently recover quickly from any major failure, minimizing downtime. However, image-level backups consume more storage and can take longer to complete compared to incremental backups. They are best suited for use cases where an entire VM, including all settings and applications, must be captured and replicated. But how do you determine which backup strategy best fits your organization? For companies like TechCorp, this decision involves evaluating factors such as recovery time objectives or RTO, the recovery point objectives or RPO, the cost, and the criticality of their workloads. For example, snapshots are ideal for temporary backups, such as before system upgrades, but they are limited for long-term retention and may lack consistency for applications that require in-memory data. While incremental backups provide an efficient, scalable option for frequent backups of production systems, especially for databases or systems with high transaction rates, they are best for maintaining data consistency while reducing storage costs. And image-level backups are most suitable for disaster recovery scenarios where full VM restoration is required. They ensure that an entire system, including the OS, is recoverable in the event of a failure. However, for many organizations, a hybrid backup strategy that combines multiple approaches often proves to be the most effective solution. For instance, TechCorp might employ snapshots for short-term protection, incremental backups for daily operations, and image-level backups for critical systems requiring full disaster recovery. By combining these strategies, TechCorp can minimize costs while maximizing data protection. Snapshots give them quick rollback options, incremental backups reduce the storage footprint for frequent backups, and image-level backups ensure the ability to recover entire VMs when needed. This layered approach allows TechCorp to meet both its operational needs and compliance requirements. Azure's flexibility through services like Azure Backup makes it easy to configure and manage these different strategies. IT administrators can set policies to automate incremental backups, while critical systems can be protected using full image-level backups, all within a single unified platform. Azure offers a flexible suite of options for virtual machine backups, enabling organizations to select the most suitable strategy for their unique needs. Snapshot-based, incremental, and image-level backups each bring distinct benefits, and when combined, they provide comprehensive protection across diverse workloads. For companies like TechCorp, leveraging Azure's backup solutions ensures data integrity, reduces downtime, and optimizes costs. The key is to understand your organization's specific requirements and customize your backup approach accordingly, enabling fast recovery from disruptions and maximizing both storage and backup efficiency. Maintaining virtual machines or VMs is crucial for organizations as it ensures effective backup strategies are in place to protect against data loss and reduce downtime. For example, imagine Brightwave Technologies, a company that relies on Azure VMs to power its services. For Brightwave, managing and securing data is like setting up a protective network for a city's infrastructure. Just as a city needs emergency protocols and resources to handle power outages, Brightwave requires a reliable backup strategy to protect its digital assets from unexpected disruptions. Through Azure, Brightwave has a scalable environment for managing VMs, but configuring backups is essential to keep its operations running smoothly and prevent costly data loss. This video will demonstrate how Brightwave Technologies sets up VM backups in Azure, illustrating how the company has built a comprehensive backup solution to ensure data resilience and maintain service availability even during unexpected events. Your first step is to sign in to the Azure portal. To do this, simply navigate to the Azure portal and enter your credentials. Once you're logged in, you'll have access to all your Azure resources, including VMs, and you can begin the configuration process. Now, let's create a Recovery Services Vault, which is required to store backups in Azure. You can create one by following these steps. Search for Recovery Services Vaults in the top search bar of the Azure portal, then click Create. Now select your subscription and choose the appropriate resource group. Next, enter a name for the vault and select the region where it should be stored. And lastly, click Review plus Create and then Create to finalize the process. This vault will serve as a central storage location for all VM backups in your environment, offering both security and redundancy. It is critical to ensure that the Recovery Services Vault is located in a region that aligns with your data residency or compliance requirements. Once the Recovery Services Vault is created, it's time to configure the backup policies, which are essential for defining the backup schedule and retention periods. You do this by, firstly, navigate to the Backup Policies section within the Vault under Manage. Now, click on Add to create a new backup policy and select Azure Virtual Machine. Now, define the backup schedule by choosing the frequency and setting the time at which the backup job should start. Then, you need to configure the retention settings based on your business requirements. This could be daily, weekly, monthly, or yearly retention. You should consider longer retention periods for critical data, as this will ensure multiple recovery points over an extended period. It's important to note that backup policies help ensure that backups occur automatically and at regular intervals, reducing the risk of data loss while allowing for flexible retention periods. Now, once your Recovery Services Vault and backup policies are in place, you can select the VM to backup. Starting in the Recovery Services Vault, navigate to Backup under Getting Started. Now, choose Azure Virtual Machine as the workload. And select Backup to configure it. Next, choose the policy subtype, then click Add to select the VM from the list of available virtual machines in your resource group. Lastly, click Enable Backup to link the VM with the backup policy created earlier. Remember, selecting the right VM is critical to ensuring the protection of mission-critical VMs. VMs with sensitive data or production applications should always be prioritized when configuring backups. Now it's time to enable the backup manually. Start by selecting the Recovery Service Vault and in the Backup Items section under Protected Items, review the selected VM and the backup policy. Then click Backup Now to start the initial backup job. This will trigger the first backup of the selected VM. Depending on the size of the VM and the data involved, this process may take some time. Once completed, you'll have a recovery point stored in your Recovery Services Vault, providing you with the ability to restore the VM in case of failure. After enabling backup, it's important to regularly monitor and manage the backup status to ensure everything is functioning as expected. You can do this by going to Backup Jobs in the Recovery Services Vault under Monitoring. This will show you the status of each backup job. You can also set up alerts and notifications for failed or incomplete backups by configuring Azure Monitor rules. This monitoring helps ensure that backups run smoothly and any issues are promptly addressed, preventing lapses in protection. In the event of a disaster or system failure, you may need to restore a VM from a backup. Understanding this process is essential for quickly recovering your system when needed. You can do this by navigating to Backup Items in the Recovery Services Vault and selecting the VM you want to restore. Then, choose the appropriate recovery point from the list. Next, click Restore VM and choose whether to restore the VM to its original location or create a new one. And lastly, click OK to initiate the restoration process. The VM will be restored to the selected point in time, allowing you to recover from incidents like data corruption, accidental deletion, or system failures. For Brightwave Technologies, configuring VM backups in Azure is essential to maintaining business continuity and safeguarding critical data. By following this step-by-step guide, Brightwave can establish a strong backup strategy tailored to its operational needs. From setting backup schedules and retention policies to prioritizing essential VMs, each step reinforces protection against data loss or system failures. With thorough configuration and regular monitoring, Brightwave can depend on Azure's backup solutions to uphold the security and availability of its virtual machines, ensuring seamless service for clients, even in the face of unexpected challenges. Monitoring virtual machine backup jobs in Azure is essential for maintaining your cloud infrastructure. Just as a bank depends on rigorous transaction tracking, organizations managing critical data under regulatory compliance require backup tracking strategies that will safeguard data integrity, prevent losses, and maintain compliance. Without consistent monitoring, unnoticed issues can arise, jeopardizing recovery points and exposing the organization to risks of data loss or compliance breaches. In this video, you'll discover essential tools and strategies to monitor Azure VM backups effectively. You'll cover how to use Azure Monitor for real-time insights, Explore methods to review backup logs for a detailed understanding of backup health and learn how to configure alert notifications. Let's start with Azure Monitor, which tracks the health and status of backup jobs across your Azure VMs. It's a comprehensive tool that gathers data across different Azure services, including Azure Backup, and enables IT administrators to visualize performance metrics, query logs, and set up notifications. By integrating Azure Monitor with Azure Backup, you can track in-depth metrics such as backup completion times, data transfer rates, and the overall success or failure of each backup job. Once Azure Monitor is integrated, it will automatically collect the following metrics from Azure Backup: the backup job success rates, the data transferred, and the duration of the backup job. Additionally, log analytics within Azure Monitor allows for the creation of detailed queries to extract deeper insights. You can create custom log queries to track anomalies in backup jobs or delays in their completion. Azure Monitor also provides customizable dashboards that display the metrics collected. You can visualize backup job trends over time, monitor potential failure patterns, and understand how resource-intensive your backups are. For instance, your IT team, responsible for backing up numerous critical VMs with transactional data, might establish a centralized dashboard to monitor backup durations across the entire infrastructure. This setup allows them to quickly spot any backup jobs that consistently take longer than expected, potentially signaling underlying storage issues that require immediate attention. Another essential component of monitoring backup jobs is reviewing backup logs, which are vital for troubleshooting issues and ensuring backup consistency. Azure provides built-in logging mechanisms for all VM backup jobs, which allow you to review the entire process and pinpoint where a problem might have occurred. Azure Backup logs every backup job with detailed status reports. These logs contain information such as the start and finish times, the amount of data backed up, and any error messages if the job failed. Administrators can access these logs directly through the Azure portal by navigating to the Backup section under a VM's settings. Additionally, you can filter and search logs by time, type of backup, and status. This helps identify patterns such as recurring failures on specific VMs or times of day when backups are more prone to delays. Azure also retains backup logs for a designated period, allowing administrators to access historical data for trend analysis or to troubleshoot intermittent issues. This log retention ensures that important insights are always available when needed. For example, imagine a manufacturing company using Azure VMs to run critical software and control its production lines. When their nightly backup jobs fail, IT admins review the logs to discover that a recent update to one of the VMs caused the backup agent to malfunction. By examining the log details, they can trace the issue back to the update and resolve it, ensuring that production data remains safe. Another proactive approach to monitoring backups is to set up alerts that notify administrators of backup failures or significant delays. Azure provides robust tools to configure such alerts using both Azure Monitor and the Azure Backup service. You can create alerts in Azure Monitor by navigating to Azure Monitor and creating a new alert rule. Then, choose the backup item's resources as the scope and select the condition based on backup job metrics. Lastly, the notification action should be specified, such as sending an email, SMS, or triggering an automated remediation script. You can also fine-tune alert conditions based on specific needs. For example, you may want an alert if the backup job fails more than 3 times in a row or if it exceeds the expected duration by a certain percentage. Alerts can also trigger automated actions such as rerunning the backup job or scaling up the storage resources if it is detected that a backup job is consistently failing due to capacity issues. For example, imagine a large retail company that relies on daily VM backups to secure customer data. After experiencing a series of failures, their IT team sets up alerts to notify them whenever a backup fails or takes longer than 60 minutes. When an alert triggers due to a failure, the IT team can quickly act, minimizing any potential data loss or operational downtime. As witnessed, monitoring virtual machine backup jobs in Azure is critical to ensuring business continuity and data security. Azure Monitor, backup logs, and alert configurations provide a powerful toolkit for administrators to oversee their backup operations efficiently. Corporate companies can leverage these tools to maintain their backup schedules, detect issues early, and ensure that they meet both operational and regulatory requirements. By proactively managing their backups, organizations can reduce the risk of data loss and avoid potential service disruptions, allowing them to focus on core business activities. Congratulations on completing the first module. You've now gained a solid understanding of Azure Backup concepts and developed the skills required for effective backup configurations. This module has prepared you not only to implement backup strategies, but also to understand how they can benefit your company in real-world scenarios. You should now have a strong grasp of the fundamental concepts of backup strategies, the steps for configuring file and folder backups in Azure, and techniques for setting up virtual machine backups in Azure. Before you take the module quiz, let's recap what you've learned to ensure you're ready. You began by exploring the fundamental concepts of backup and its importance for maintaining data integrity and ensuring business continuity. Key terms such as incremental backups, full backups, and the 3-to-1 backup rule were covered, laying the groundwork for effective backup strategies in the Azure environment. You then discovered various options Azure offers before a reading elaborated on the importance of establishing a routine backup strategy. This highlighted scenarios where data loss can occur and the role of regular backups in mitigating these risks. By the end, you understood the necessity of implementing a robust backup routine to secure critical information. Different backup methodologies and strategies were then explored. These included full backups, incremental backups, differential backups, and off-site backups, which all aim to ensure business continuity and disaster recovery preparedness. Following this, you studied regulatory compliance standards such as GDPR, HIPAA, and SOC 2. You also explored measures such as encryption, access control, and audit trails to protect data integrity throughout the backup lifecycle. A follow-up reading then provided insights into configuration options, best practices, and troubleshooting tips. Next, you engaged in a technical exploration of configuring file backups in the Azure environment, concentrating on specific steps and best practices. You examined the Azure Backup interface, highlighting key configuration settings, and learned the nuances of selecting and safeguarding individual files, equipping you to set up file backups for critical data protection efficiently. Following that, you covered best practices for configuring folder backups, including folder structure, inclusion-exclusion criteria, and scheduling, ensuring that folder backup configurations were effective and aligned with organizational needs. You also learned how to set up monitoring alerts, review backup logs, and troubleshoot common issues to ensure the smooth operation of file and folder backup processes in Azure. Next, you examined a real-world case study that demonstrated how effective file backup configurations help prevent data loss. It offered practical insights into the challenges faced and solutions implemented. Then, a video on backing up virtual machines in Azure explored various strategies such as snapshot-based backups, incremental backups, and image-level backups, which are essential for tailoring backup approaches to specific business requirements. Toward the end of the module, you completed a hands-on, step-by-step guide for configuring virtual machine backups within Azure. It covered everything from selecting VMs to defining backup schedules and retention policies. The last section of the module explored tools and techniques for monitoring the progress and status of virtual machine backup jobs in Azure. It included how to use Azure Monitor, review backup logs, and set up alert notifications for backup failures or delays. Throughout this module, you have explored a variety of videos, readings, and activities that helped you build a solid foundation in Azure Backup. With this essential knowledge, you're now better equipped to make informed decisions for your organization, moving you closer to your goal of becoming a cloud support professional. Your final step in this module is to complete the quiz. But before you proceed, if this video brought up any areas you'd like to revisit, take a moment to review the relevant content to ensure you're fully prepared. Keeping your VMs updated is a critical step in maintaining security, performance, and stability. Failing to apply updates not only leaves your environment exposed to vulnerabilities, but can also degrade system performance over time. This video will focus on the security benefits of regular updates, illustrated with real-world scenarios and best practices to ensure your VMs remain secure. Cyber attackers constantly search for vulnerabilities in outdated software and infrastructure. Vendors like Microsoft regularly release patches to fix these vulnerabilities. However, failing to apply updates leaves your system exposed to security risks. In 2017, the WannaCry ransomware attack exploited a vulnerability in the Windows Server Message Block or SMB protocol using an exploit known as Eternal Blue to spread the WannaCry ransomware worm. Once in a system, WannaCry would encrypt files, lock out users, and demand a Bitcoin ransom to decrypt the data. This exploit spread rapidly across networks, affecting both physical systems and virtual machines alike. Microsoft had actually released a patch 2 months before the attack, but many systems remained unpatched, leaving them vulnerable. The widespread impact, which affected sectors from healthcare to financial services, underscored the critical importance of timely patch management and security updates for all systems, including VMs, to mitigate the risk of such attacks. Another consideration when it comes to updates is compliance requirements. Organizations often need to comply with security standards like GDPR, HIPAA, and SOC to protect data privacy, integrity, and security in systems. Regular updates are crucial for maintaining compliance, as most regulations require systems to be protected against known vulnerabilities. Therefore, establishing a robust update policy that ensures security and compliance with legal and regulatory requirements is best practice, reducing the risk of penalties and security risks. Furthermore, updates often include performance enhancements that improve the efficiency and speed of your systems. This helps maintain security and stability under heavy workloads. For example, updates might address memory management optimizations that prevent memory leaks, which could otherwise lead to VM crashes or resource exhaustion vulnerabilities. Additionally, updates can include CPU optimizations to avoid inefficiencies that attackers might exploit to disrupt service. Network performance improvements are another focus, helping to reduce latency and ensure resilient access, which is particularly beneficial in environments facing high traffic or potential network-based attacks. Let's examine some specific risks of skipping updates a little closer. First, without regular updates, systems become increasingly vulnerable to known exploits. As exemplified by the WannaCry attack, hackers can use these unpatched vulnerabilities to gain unauthorized access or disrupt operations. An example is a financial organization that suffers a data breach because it delayed patching a critical vulnerability in its web server, exposing sensitive customer data. Second, systems that aren't regularly updated may experience increased instability, resulting in downtime, crashes, or other performance issues. System instability from outdated software increases the chances of exposing unresolved bugs that attackers could exploit, potentially gaining unauthorized access to sensitive data. For instance, an unpatched VM operating system may become unresponsive during high-demand periods or introduce security loopholes that hackers can use to disrupt operations, risking data loss and revenue impact. Lastly, delaying updates can prevent your systems from leveraging new features and enhancements that improve functionality and security. For example, by delaying updates, you may miss out on important improvements such as enhanced virtual machine management tools, new security features, or more efficient resource allocation. Automating the update process ensures that your systems remain secure without requiring constant manual intervention. Previously, the Azure service that provided automation capabilities was Automation Update Management, but it was replaced with Update Manager in September 2024. Azure Update Manager offers improved insights into update compliance, simplifies update scheduling, and provides enhanced features for managing operating system updates across cloud and hybrid environments. Although some companies continue to migrate from Azure Automation Update Management to Azure Update Manager, let's focus on Update Manager for now. Let's discuss some best practices to follow when it comes to updates. You should ensure that critical and security updates are prioritized while non-critical updates are scheduled for off-peak hours. Next, regularly monitor and audit your VMs to ensure that they are fully patched. Microsoft Defender for Cloud provides comprehensive security monitoring for VMs, including missing updates, and provides actionable recommendations to help you stay protected. You can also use Azure Policy to enforce update compliance across all your subscriptions. Even with well-managed updates, unforeseen issues may occur. For critical workloads, a failover plan ensures minimal disruption. Azure Availability Zones and Availability Sets ensure critical workloads remain operational during updates. Availability zones are physically separate locations within an Azure region. Placing VMs across zones can protect against data center level failures. If one zone goes down, the workloads in other zones remain operational. On the other hand, availability sets organize multiple virtual machines within a single data center, distributing them across separate fault domains and update domains. Fault domains place VMs on distinct physical hardware, while update domains stagger updates across different groups. This design helps to minimize disruptions, as updates are only rolled out to one domain at a time, ensuring continuous availability. You can also leverage Azure Site Recovery to create failover solutions that minimize downtime during maintenance windows. Maintaining regular updates for virtual machines is key to ensuring a secure, compliant, and efficient Azure environment. By automating updates, leveraging Azure tools, and implementing best practices, you can protect your infrastructure from vulnerabilities and ensure continuous system performance. As discussed, regular updates are essential. Now let's examine Azure's automated patching process, focusing on how Azure Update Manager streamlines update deployment. Additionally, we'll discuss how automatic VM guest patching provides further automation to keep VMs secure without manual input. Azure's patching system is designed to automatically manage operating system updates for virtual machines, ensuring that your infrastructure remains secure and up-to-date with minimal manual input. Understanding how Azure handles patching will help you make informed decisions about configuring and optimizing your update process. Azure prioritizes updates based on their importance. Updates often include feature improvements, performance enhancements, and bug fixes. These contribute to overall system stability. However, security patches are viewed as the most critical updates aimed at fixing vulnerabilities and safeguarding your environment. By automating security updates, Azure ensures that the most critical patches are applied promptly, minimizing the risk of exposure to vulnerabilities. Azure Update Manager centralizes the process of scheduling, deploying, and tracking updates across both Windows and Linux VMs. Through a unified interface, it allows administrators to schedule updates. Administrators can create regular maintenance windows to ensure updates are deployed during non-critical hours, reducing the risk of disruption to production workloads. Secondly, it assesses compliance by continuously monitoring the patch status of your VMs. This ensures that all critical patches are applied and you're alerted to any non-compliant machines. While Azure Update Manager offers robust control over the update process, automatic VM guest patching takes automation a step further, making the patching process even more seamless. This feature is specifically designed to automatically install critical updates on your virtual machines, ensuring they remain secure. Automatic VM guest patching ensures that virtual machines receive critical updates as soon as they are available without requiring custom scheduling or manual patch management. Optional updates, feature enhancements, or non-security patches are excluded from the critical update process, allowing administrators to retain control over those updates. Additionally, based on Azure's understanding of your VM's activity, patches are applied at a time that minimizes potential disruption. This ensures that patching does not interfere with your operations. Automatic VM guest patching has several benefits. First and foremost, it enhances security. By automatically applying critical patches, Azure reduces the window of exposure to known vulnerabilities, making infrastructure more resilient to security threats. The second is reduced administrative overhead, as administrators no longer need to manually track and apply critical security updates for each VM. This reduces the time spent on patch management. And lastly, automatic guest patching is enabled by default for new virtual machines, meaning you can benefit from this feature without additional setup. However, some configuration is still required for comprehensive patch management. Azure provides various tools and settings for controlling when and how updates are applied to virtual machines. This brings us to patch orchestration, which allows administrators to define the specific timing and sequence of patches to ensure updates align with operational needs and avoid disruptions. When creating a VM via the Azure portal, you can configure patch orchestration modes under the Management tab. This setting is available for both Linux and Windows virtual machines, giving you control over how patching is managed within your environment. Even with automatic patching in place, it's essential to maintain visibility over your VM's patch status. Azure Update Manager, with its seamless integration into Azure Monitor, provides a suite of tools that help administrators monitor and ensure patch compliance across all VMs. This integration enables in-depth reporting, alerting, and monitoring features, allowing administrators to track which patches were applied, when they were applied, and whether any issues occurred during the process. For example, it provides real-time compliance assessments for your virtual machines, ensuring that all required patches have been applied. This centralized view helps you track the patch status of all VMs, whether they are in Azure, on-premises, or in other cloud environments. Furthermore, through Azure's reporting tools, you can generate detailed reports on patch compliance and receive alerts for any machines that are non-compliant or have failed to apply updates. This allows you to quickly address any issues before they pose a risk to your environment. If a critical update fails or a VM falls out of compliance, Azure Update Manager can notify you immediately, ensuring that your team can take swift corrective action. It also provides intuitive dashboards that display the patch status of all VMs at a glance, allowing for quick identification of issues. The best approach to patch management often involves combining Azure Update Manager and automatic VM guest patching. Here are a few best practices to follow. Firstly, you should enable automatic guest patching to ensure that critical security updates are applied automatically. This reduces the risk of vulnerabilities while minimizing manual oversight. Secondly, use Azure Update Manager to schedule updates for non-critical patches and performance improvements during maintenance windows that suit your operational needs. This gives you control over less urgent updates while ensuring business continuity. You should also regularly review your patch compliance reports and take advantage of Azure's alerting system to address any non-compliant VMs. Proactive monitoring ensures that your environment remains secure and up-to-date. In summary, Azure's patching ecosystem, which includes Azure Update Manager and automatic VM guest patching, provides a comprehensive and automated solution for maintaining the security and stability of virtual machines. While Update Manager gives you centralized control over scheduling and compliance tracking, automatic guest patching ensures that critical security updates are applied without manual intervention. By using both tools together, you can minimize risk, reduce administrative overhead, and keep your VM secure with minimal disruption. You're already familiar with the importance of regular updates and patch management. Now it's time to explore in more detail how Azure streamlines the process with automation. This video will give you insight into Azure's automation capabilities, best practices, and some advanced configurations that will enable you to set up effective and efficient update management in your Azure environment. Automating updates is more than just a convenience. It's a strategic decision for maintaining operational efficiency and security. A fully automated patch management system ensures that critical security patches are deployed as soon as they're available without waiting for manual approval or implementation. Without automation, IT teams are forced to manually track the release of updates, schedule downtime for patching, and ensure that patches are applied to all relevant machines. This manual approach not only increases the risk of human error, but also leaves systems vulnerable to known threats for extended periods. Automation mitigates these risks by ensuring timely patch application with little to no oversight. Azure's automation tools, specifically Azure Update Manager, streamline this process by providing a centralized platform to manage, schedule, and monitor updates across your VM fleet. Once you've configured the basic automatic update settings, Azure offers several advanced features and configurations to refine and optimize your update strategy. While automatic VM guest patching ensures that critical security patches are applied, there may be other types of updates that are important to your environment. Azure allows you to classify patches based on their importance, giving you greater control over what types of updates are automatically applied. These updates include feature updates that introduce new functionality or enhancements to the operating system. You may want to manually schedule these updates outside of peak business hours to avoid disruptions. There are also optional updates that can include drivers, non-security patches, or other updates that may not be immediately necessary. With Azure, you can choose to apply these during scheduled maintenance windows, ensuring they don't interfere with critical operations. Azure provides two primary options for managing patch orchestration. You already know about Azure Managed or Automatic Guest Patching. This is the most hands-off approach where Azure handles everything related to patching your VMs. This is ideal for workloads where security and uptime are the priority, and you don't need granular control over when updates are applied. For most scenarios, Azure Managed Patch Orchestration is the recommended approach as it minimizes the risk of missed updates and reduces administrative overhead. Customer Managed or Manual Patching, on the other hand, is for environments that require strict control over the timing of patches. Customer Managed Orchestration allows administrators to schedule patches during specific windows. This can be useful for high availability environments where downtime must be minimized and carefully coordinated. A challenge with Customer Managed Patching is finding a time that minimizes disruption to your operations. While Azure's automatic updates can apply patches in the background, certain updates, like feature updates, may still require downtime. To accommodate this, Azure allows you to define maintenance windows, ensuring that patches are applied during periods of low activity. By scheduling these maintenance windows, you can minimize the impact of updates on users or business-critical operations, ensure that VMs are updated during non-peak hours, reducing the chance of performance degradation, and align patch schedules with other routine maintenance tasks to streamline overall IT management. Maintenance windows are particularly important for organizations that operate across multiple time zones or have global workloads. Configuring region-specific maintenance windows allows you to apply updates in a staggered manner, ensuring that customers in critical regions do not experience downtime. It is necessary to periodically evaluate and adjust maintenance windows and update schedules based on changes in business operations or workload demands. This is to ensure the update process remains efficient and minimally disruptive. Furthermore, whether it's automated or manual patching, it's essential to monitor the compliance of your virtual machines. Azure's Update Manager provides a comprehensive view of the patch status of all your virtual machines, allowing you to identify any non-compliant VMs that may have missed a critical update. Some key features include compliance dashboards. These visual dashboards provide a real-time view of patch compliance across your entire VM fleet. With this feature, you can quickly identify VMs that are missing critical updates and take immediate corrective action. You can also set up alerts to notify your team when a VM falls out of compliance or when a critical patch fails to apply. This ensures that any issues are addressed promptly, reducing the risk of vulnerabilities being exposed. Additionally, Azure provides detailed logs of all patches applied to your VMs. This gives you visibility into when patches were applied, what was updated, and whether any issues occurred during the process. Ultimately, keeping track of patch compliance ensures that your virtual machines remain secure, compliant, and up-to-date at all times. Configuring automatic updates for your Azure VMs is a critical step toward maintaining a secure, compliant, and efficient cloud environment. By leveraging Azure's automation tools, scheduling maintenance windows, and monitoring compliance, you can ensure that your virtual machines remain up-to-date without manual intervention or disruptions to your operations. With these configurations in place, you can confidently reduce security risks, improve operational efficiency, and free up valuable time for your IT team to focus on higher value tasks. Automation and scheduling are essential for managing updates effectively. But occasionally, patching issues can arise, leading to update failures or leaving machines non-compliant. Thus, ensuring that patches apply smoothly across all virtual machines is equally critical. This video addresses common patching issues and discusses how to troubleshoot them in Azure, ensuring the security and stability of your environment. Azure provides several tools for diagnosing and resolving patching failures, such as compliance reports, error logs, and resource health diagnostics. Leveraging these resources allows you to pinpoint the cause of patching issues, address them quickly, and maintain the security of your infrastructure. Let's explore some tools and how they work. First up are update compliance reports that you can access via the compliance dashboard in Azure Update Manager. These offer an overview of the patch status for all VMs in your environment. This dashboard quickly shows which VMs are compliant and highlights those with missed or failed updates. Being able to immediately identify which VMs are vulnerable because they missed a patch allows you to prioritize troubleshooting for non-compliant VMs and focus on machines that need your attention. For detailed error insights, you can make use of Log Analytics Workspace and Azure Monitor, which integrate with Azure Update Manager to provide in-depth logs for all patching activities. These logs capture details on both successful and failed patch applications, as well as error messages that help pinpoint specific issues. Let's say a VM fails to install a critical security patch due to a disk space issue. By navigating to Log Analytics and filtering by the VM's name, you can view specific error messages related to the update failure, such as insufficient disk space. This helps you identify the root cause and take corrective action, such as increasing disk capacity. For example, to specifically identify VMs that missed critical security updates, you can use Custo Query Language or KQL queries in the Logs section. KQL is a powerful query language used to retrieve and analyze large datasets in Azure. This query checks for critical updates over the past 7 days that were not successfully installed, grouping results by each VM and update status. Running this query can highlight VMs with critical updates pending installation, allowing you to take immediate action on those machines. Log Analytics, with custom queries like the one just shown, enables precise filtering and categorization of errors, helping administrators quickly locate and troubleshoot specific patching issues. Next, there is Azure Resource Health. It provides a historical view of each VM's health status, showing any recent outages, connectivity issues, or performance concerns that may impact updates. Suppose a patch fails to apply on a VM due to a temporary network outage. By checking Azure Resource Health, you notice that the VM's status was marked unhealthy during the time of the update. This confirms that the patching issue was likely caused by network instability. Resource Health provides additional context around failed updates by indicating if external factors like connectivity or performance issues affected the VM during patching. This is particularly useful for identifying issues outside of the VM's configuration that may impact patching success. Lastly, you also have automation runbook logs at your disposal. For environments using custom automation runbooks to manage patching, the logs generated by these runbooks offer detailed insights into each step executed during the patching process. A runbook is a set of automated instructions or scripts used to perform routine tasks or processes. These help identify any misconfigurations or interruptions in the automation workflow. For instance, imagine you've configured a runbook to apply patches and reboot a VM. After reviewing the runbook logs, you find that the reboot step failed due to a misconfigured script. This failure led to an incomplete patch application, as the VM did not restart as required to finalize the update. By identifying the specific runbook step where the failure occurred, you can correct the script and ensure that future updates are completed successfully. Runbook logs provide step-by-step visibility into automated patching processes. This makes it easier to troubleshoot and refine automation scripts or configurations for smoother update deployment. In summary, troubleshooting patching failures is essential for maintaining a secure and compliant Azure environment. By utilizing tools like Update Compliance Reports, Azure Monitor with custom queries, Azure Resource Health, and Runbook logs, you can efficiently identify and resolve patching issues. These tools provide the insights needed to address problems proactively, keeping your virtual machines up to date with minimal disruption. Effective patching approaches are essential for managing large-scale and complex Azure environments. These methods help orchestrate patching across regions, address dependencies, and customize schedules for critical workloads, ensuring seamless updates with minimal disruption. Let's explore some of these techniques, starting with regional patch orchestration. For environments with VMs spread across different regions, orchestrating patches regionally allows for continuous service availability while updates are applied. Azure Update Manager enables you to schedule updates in a staggered manner across regions. By patching one region at a time, you can ensure that services remain available in other regions, providing redundancy during the update process. Imagine you have a globally distributed application with VMs in North America, Europe, and Asia. You can configure Azure Update Manager to apply updates in North America first, monitor the process, and then proceed to Europe and Asia. This regional approach helps avoid simultaneous downtime across all regions. Next, you need to handle dependencies in patching. Some patches may have specific dependencies that need to be managed carefully, such as updates requiring certain applications, system libraries, or previous patches to be installed first. Azure Update Manager allows you to set custom patching orders or prerequisites to handle these dependencies. Additionally, by using PowerShell scripts or runbooks, you can automate the sequencing of patches to ensure each VM is properly updated without missing critical dependencies. For example, you can set up a runbook in Azure Automation to apply the initial patch, verify its success, and then apply the subsequent updates for an application that requires a specific security patch to be installed only after a prerequisite update. This sequential approach ensures that all necessary components are in place for the patch to function as intended. Sequencing patches based on dependencies reduces failures, especially in layered applications, for smoother updates. Another strategy is to implement custom maintenance windows. These allow you to designate specific periods for patching VMs based on workload requirements such as low traffic periods or scheduled downtimes. For instance, production VMs can be scheduled for updates during off-peak hours, while development and testing VMs can be patched during regular business hours. Aligning updates with low traffic periods avoids interruptions for critical workloads, ensuring service continuity. You can also group VMs based on characteristics such as environment type, like production or development, operating system, or criticality, allowing for efficient and targeted patch deployment across a large-scale VM fleet. Azure Update Manager lets you define patch groups by tagging VMs or using resource groups. This enables you to apply updates to specific sets of VMs with similar characteristics, ensuring each group is maintained according to its unique needs. For example, in a complex environment, you may create separate patch groups for Windows VMs, Linux VMs, and database servers. Each group can then receive tailored updates, with Windows VMs receiving security patches, Linux VMs receiving kernel updates, and database servers receiving specific performance patches. Grouping VMs by type allows for efficient, targeted updates, streamlining patch management in diverse environments. Another technique you can use is to automate patch validation with test environments. Testing patches in a staging or test environment before applying them in production is crucial to identify and mitigate potential issues. Azure Update Manager combined with Azure Dev Test Labs allows you to set up a test environment mirroring production configurations. By automating patch validation in this environment, you can identify any issues before deploying patches to critical production VMs. For instance, imagine you are managing a financial application. Before updating production VMs, you apply the patches in a staging environment using Azure Dev Test Labs. Automated tests verify the patch compatibility and performance. Once validated, the same patches are deployed to the production environment with minimal risk. In this way, testing patches in a staging environment first helps prevent issues in production, reducing potential disruptions. Finally, it is good practice to automate rollbacks for patch failures. An automated rollback plan ensures that if a patch fails to apply correctly, the system can revert to a stable state, minimizing downtime and disruption. By integrating Azure Update Manager with Azure Backup, you can automate the backup of VMs before applying patches. If a patch fails, you can quickly restore the VM to its previous state from the backup. For example, for a healthcare application, you can schedule pre-update backups to ensure recovery options in case a patch affects VM stability or application performance. The benefit of this strategy is that it minimizes downtime by restoring VMs from backups when patch failures occur, supporting high availability. Ultimately, efficient patching in Azure ensures seamless operation and high availability even across complex, large-scale environments. Using the Azure Update Manager and the techniques and strategies discussed in this video, you can manage updates more effectively and keep workloads secure while ensuring consistent performance. When you're running a critical business application, downtime during peak hours can be disruptive. With Azure Update Manager's scheduled patching, you can set maintenance windows that perfectly align with your operational needs. In this video, you'll learn how Azure Update Manager's scheduled patching automates updates across your virtual machines. Let's start by accessing Azure Update Manager. In the Azure portal, type Azure Update Manager in the search bar and select it from the results. The Update Manager dashboard will open, where you can manage updates for all connected virtual machines. Navigate to the left-hand menu and select Machines under the Manage section. The page that opens displays your connected VMs with their update status and configurations. Next, select the specific VM or group of VMs you want to schedule updates for and then select Scheduled Updates. This opens the Create a Maintenance Configuration page. Now it's time to set up a schedule and define a maintenance window. This specifies when updates should be applied. In this example, updates will be scheduled for a single VM. Start by selecting the subscription and resource group. Keep in mind that only VMs and maintenance configurations within the same subscription are supported in Azure. Now move on to the instance details. Enter a configuration name. Choose the region where this configuration will apply. Set the maintenance scope to Guest. This includes Azure VMs, Azure Arc-enabled VMs, or servers. And set the reboot setting based on your needs. Once you've completed these fields, it's time to add the schedule. Set the date and time for the schedule to start to schedule updates at a low impact time. Then, specify the maintenance window, such as up to 3 hours and 55 minutes. This controls update duration and minimizes operational impact. Next, decide how often you want the updates to repeat. You have a few options: daily, or at specific intervals such as every 2 or 3 days; weekly, where you can pick specific days of the week; or monthly, where you can set a specific calendar day or choose an nth day, such as the first or second Monday of each month. You can also add an offset, like plus or minus a few days. You may notice that the hourly repeat option is unavailable in the portal. However, this can be configured using the Application Programming Interface or API. You can also choose to add an end date for the schedule if needed. Before moving on, take a moment to review the schedule summary to make sure everything is good to go. From there, go to the Resources tab and specify which VMs this schedule applies to. You can select multiple VMs if necessary. In the Tags tab, add any tags to organize or categorize your maintenance configuration as needed. Finally, as you know by now, select the Review and Create button, review your settings, and select Create to complete the setup. To further illustrate how defining a maintenance window can help you, here's a real-world example. Let's say you're managing a production application, such as an online retail platform or a customer-facing service. You might set a maintenance window for late-night hours, applying critical updates while avoiding disruptions during peak business times and ensuring your systems remain secure and performant. With your update schedule set, let's discuss how you can control updates more precisely using Maintenance Control. This powerful feature helps you tailor update schedules to different types of resources, giving you flexibility and better management of your updates. In Maintenance Control, a scope refers to the type of resource or environment that a maintenance configuration applies to. There are 3 main scopes for maintenance configurations, each designed to tailor update schedules to specific needs. First is Host. This is perfect for isolated VMs and dedicated hosts, allowing you to schedule updates up to 35 days in advance with a minimum 2-hour maintenance window. Second, there is OS Image. This scope is designed for VM scale sets that use automatic OS upgrades. It requires a maintenance window of at least 5 hours. And finally, you can use Guest. This scope integrates seamlessly with Azure Update Manager for recurring updates on Azure VMs, on-premises machines, and other cloud environments via Azure Arc. It needs a window of 1 hour and 30 minutes to 3 hours and 55 minutes. Here are a few important points to remember when using Maintenance Control. You must have at least a contributor role and check that your subscription is registered with a maintenance resource provider. Maintenance updates won't apply if a machine is turned off, so power it on at least 15 minutes before the scheduled update. If the machine is shut down, it may show as disassociated in the Azure portal. Keep in mind that moving resources to a new group or subscription can disrupt your maintenance schedule. Also, there is a 128-character limit for resource group and configuration names. With Maintenance Control helping you manage the timing of updates, it's just as important to monitor the progress and compliance of those updates to ensure everything runs smoothly. The dashboard offers real-time insights into update statuses, showing which VMs are compliant and which ones have pending updates. With compliance reports, you can track each VM's update history, success rates, and any issues that occurred during patching. And finally, you can configure alerts to notify you if updates fail or if a VM becomes non-compliant. These alerts enable you to respond quickly to any critical patching issues. In this video, you explored how Azure Update Manager and maintenance configurations help keep virtual machines secure and up-to-date, ensuring streamlined and controlled management. By leveraging scheduled patching and customizable maintenance windows, you can align update management with business needs, reduce disruptions, and enhance security compliance across your infrastructure. As you've recently discovered, scheduled patching in Azure Update Manager simplifies automatic updates across virtual machines, strengthening security and compliance throughout your infrastructure. But what if you need to go beyond scheduled updates to ensure compliance at scale? By integrating Azure Policy with Update Manager, you can automate assessments and patch deployment, maintaining a secure, compliant infrastructure across Azure and Azure Arc-enabled servers. In this video, you'll learn how to harness these capabilities to automate update management and monitor compliance effectively. Let's start by exploring one of the most impactful tools for achieving continuous compliance and proactive management: Azure Policy's Periodic Assessment feature. This capability ensures that compliance checks are carried out automatically across Azure and Azure Arc-enabled machines, streamlining the detection of missing updates and reducing manual assessments. Furthermore, once configured, Azure Update Manager performs daily update status checks for each machine, giving you continuous compliance insights without manual intervention. Let's now walk through the steps to set up periodic assessments for virtual machines in a cloud-native Azure environment. After this, you will go through the steps of setting up the same process in a hybrid environment. Start by signing in to the Azure portal. Once you're logged in, you will be directed to the Azure portal homepage. Next, use the search bar at the top of the screen to type Azure Update Manager and select it from the results. This will open the Update Manager dashboard. Navigate to Policy under the Manage section and select Configure Periodic Checking for Missing System Updates on Azure Virtual Machines. On the Policy Definition page, select Assign Policy. This action opens the Assign Policy wizard, where you'll specify the scope and parameters needed to link Azure Policy with Update Manager for automated compliance checks. In the Basics tab, set the scope to your subscription or a specific resource group if applicable. Next, move to the Parameters tab and deselect Only Show Parameters that need input or review so that all parameter values are displayed. Then, set the assessment mode to Automatic by Platform and OS type to Windows. Note that separate policies must be created for Windows and Linux to ensure full coverage. In the Remediation tab, select Create a Remediation Task. This allows automatic corrective action to be triggered if non-compliance is detected. In the Non-Compliance Messages tab, add a custom message such as, "Your machine doesn't have periodic assessment enabled." This message will alert administrators if a machine falls out of compliance. Lastly, review your configuration settings in the Review and Create tab and select Create to initiate the policy assignment and remediation task. Now, let's complete this process for Azure Arc-enabled servers with slight adjustments for hybrid environments. Navigate to Policy in the Azure Update Manager and select Configure Periodic Checking for Missing System Updates on Azure Arc-enabled servers. On the Policy Definition page, select Assign Policy. In the Basics tab, set the scope to your subscription or a specific resource group if applicable. Then, in the Parameters tab, deselect Only Show Parameters that need input or review. Set the assessment mode to Automatic by Platform and select Windows as the OS type. On the Remediation tab, select Create a Remediation Task. Next, add a custom message for the administrator alert on the Non-Compliance Messages tab. Finally, review your configuration settings and select Create to initiate the policy. Now that you've set up periodic assessments for both Azure machines and Azure Arc-enabled servers, the next step is to ensure these policies are functioning as intended. Monitoring compliance helps you verify that updates are being checked automatically and that your infrastructure stays secure and compliant. To begin, search for Policy in the Azure portal and select it from the list. Then, navigate to the Compliance section and select Configure Periodic Checking for Missing System Updates on Azure Virtual Machines. You may need to wait for approximately 30 minutes for initial compliance data to populate. Here you can view the compliance status and confirm that updates are being tracked as expected. Repeat this step for Configure Periodic Checking for Missing System Updates on Azure Arc-enabled servers to ensure comprehensive monitoring. With your policies in place, you can further enhance efficiency by automating update assessments and tracking compliance at scale through Azure Policy. This approach brings key benefits. First is centralized monitoring. Once periodic assessments are set up, Azure and Azure Arc-enabled servers will report their update status daily, giving you continuous insight into compliance across your infrastructure. And second is real-time reporting. Azure Update Manager offers detailed compliance reports that allow administrators to track patching status, identify non-compliant machines promptly, and address update issues effectively. As a final step to optimize your update management strategy, set up proactive alerts in Azure Update Manager to quickly respond to critical patching events like missed updates or VM non-compliance. These alerts help minimize vulnerabilities and strengthen your infrastructure's security posture. In this video, you explored techniques for automating assessments and tracking compliance using Azure Policy and Azure Update Manager. By integrating these tools, you can strengthen your update management strategy, ensuring consistent monitoring and proactive issue resolution. Patch compliance reporting in Azure Update Manager is like a vehicle inspection, pinpointing issues to keep your virtual machines or VMs in top condition. Compliance reporting enables you to monitor, enforce, and confirm that essential updates are being consistently applied across your VMs, maintaining both security standards and operational stability. In this video, you'll broaden your knowledge of how to manage updates by exploring compliance reporting. You'll learn how to configure, interpret, and leverage compliance reports to quickly spot non-compliance, resolve update issues, and secure your VM environment. Let's start by understanding why patch compliance reporting is so important. Firstly, compliance reporting provides visibility into each VM's update status, highlighting non-compliant machines that may pose security risks. Furthermore, many organizations must adhere to industry regulations requiring regular updates and documented compliance. Patch compliance reports can be used as evidence during audits to demonstrate adherence to updated policies. Lastly, tracking compliance also enables administrators to identify and address any gaps in update management quickly, reducing the likelihood of operational disruptions caused by outdated software. Now let's explore the configurations needed in Update Manager to activate compliance reporting. The first step to take is to ensure that each VM is registered with Azure Update Manager and linked to a log analytics workspace. Compliance tracking uses log analytics to collect and store data, making it accessible for reporting. Next, you need to establish compliance policies within Update Manager to set standards for each VM group. For instance, production VMs might require critical updates to be installed within 7 days, while development VMs may have a less stringent 30-day compliance window. Azure Update Manager allows you to define policies by update classification and schedule, so compliance requirements are customized based on the VM's role and criticality. You also need to schedule regular compliance checks to ensure that your VMs align with the policy standards. For instance, scheduling compliance assessments weekly can help detect non-compliant machines promptly and trigger remediation steps. Compliance reports in Azure Update Manager provide a breakdown of update statuses with indicators showing which VMs are compliant and which are not. Some common statuses include compliant. This is where the VM meets all update requirements within the defined time frame. Next is non-compliant, which occurs when the VM is missing one or more updates based on the compliance policy. And partially compliant. This is when the VM has some updates but may have missed certain critical patches. Here's how this works in practice. Imagine a large fleet of VMs supporting your organization's platform. During scheduled patching, a subset of VMs in one region might show up as non-compliant due to network issues. By catching this early through compliance reports, you can resolve the connectivity problem and reapply patches, preventing any disruption to your service. Another powerful feature is the ability to use Azure Log Analytics to create custom queries for deeper, more detailed insights into compliance status. For example, you could run a query to identify any virtual machines that missed critical security updates within the last 30 days. The query would look like this. This query highlights VM's missing critical updates, enabling administrators to prioritize these machines for immediate remediation. Furthermore, you can set up alerts using log analytics for conditions such as non-compliant VMs or failed updates. For instance, if a critical security update is missed, the alert can notify your operations team to take action. Use the following query to determine the overall compliance rate for VMs. This query calculates the compliance rate, helping administrators track compliance trends over time. Now let's explore how you can generate and interpret patch compliance reports. To begin, access the Compliance dashboard within Azure Update Manager to view summaries of VM compliance. You can generate detailed reports by selecting specific VM groups, timeframes, or compliance metrics. You can also use historical compliance data to identify recurring non-compliance trends. For instance, if development VMs frequently miss updates, this might suggest a need to adjust maintenance windows or schedules. For example, suppose a compliance report indicates that VMs supporting a critical application consistently have delayed updates due to maintenance conflicts. Based on this trend, you might reschedule the update window or allocate additional resources to minimize conflicts. Another key aspect of managing non-compliant VMs is setting up alert notifications. You start by configuring Azure Monitor Alerts to notify administrators of any non-compliant VMs immediately. These notifications can help your team address issues before they impact system security or operations. Furthermore, Azure Update Manager can be integrated with Azure Automation to initiate automated remediation tasks. For example, if a VM is flagged as non-compliant, an automation workflow could be triggered to apply the necessary updates automatically. For example, in high-security environments, you can configure alerts to notify the security team of non-compliance within hours of detection. This allows for rapid response and ensures that compliance is restored promptly. Lastly, let's examine how compliance reports can be leveraged for strategic planning. Firstly, you can use compliance reports to refine patching schedules. If reports show frequent non-compliance during certain maintenance windows, you should consider adjusting the patching schedule to align better with VM usage patterns. Next, many organizations require documented evidence of compliance. Compliance reports generated through Azure Update Manager can be archived and presented during audits to demonstrate adherence to security protocols and update policies. Additionally, track compliance trends over quarters or years to identify patterns and improve updated management strategies. Regular trend analysis helps with strategic planning and allows you to allocate resources to areas with recurring compliance issues. For example, imagine a quarterly compliance report showing that VMs in specific regions consistently miss updates due to network instability. By analyzing these reports, you could invest in infrastructure improvements to reduce these compliance gaps and improve overall security. Patch compliance reporting is a vital component of Azure Update Manager, helping administrators ensure that updates are consistently applied across VM environments. By configuring compliance policies, using log analytics for detailed insights, setting up alerts, and generating trend reports, you can maintain a secure and well-managed infrastructure. Through regular monitoring and reporting, compliance tracking not only supports operational stability, but also aligns with audit and regulatory requirements, enhancing overall system reliability. As of August 31, 2024, Automation Update Management has been retired. Microsoft now recommends migrating to Azure Update Manager, which provides advanced features, improved compliance monitoring, and a more intuitive interface. Azure Update Manager is built to simplify update management across your virtual machines or VMs. It offers a more efficient, secure, and compliant approach. This video will guide you through each step of the migration process, providing you with clear instructions to ensure a seamless transition. Adopting Azure Update Manager provides several benefits that enhance your operational efficiency and keep your systems aligned with Azure's latest security and compliance standards. Specifically, Azure Update Manager is a unified solution that supports Azure, hybrid, and on-premises environments, giving you greater control over all your systems in one platform. Consolidating update management across these environments eliminates the need for multiple tools, streamlines your processes, and improves efficiency. It also offers detailed real-time compliance insights, supporting regulatory and operational standards more effectively than the retired service. And lastly, with improved scheduling options, the Update Manager supports custom maintenance windows and update policies tailored to various workloads. Before beginning the migration, please ensure you meet the following prerequisites. Firstly, you should confirm that each VM, including those in hybrid and on-premises environments, is connected to a log analytics workspace. You can use log analytics for data collection and monitoring. Unlike Azure Update Management, Azure Update Manager does not connect to log analytics. The Azure Update Manager logs are available in Azure Resource Graphs. These graphs also use the Custo query language, allowing you to query log analytics and Azure Resource Graph logs simultaneously. Additionally, confirm that you have the required permissions set up with either owner or contributor roles assigned within Azure Update Manager. Finally, review any custom schedules, maintenance windows, or baseline policies currently configured in Automation Update Management. You'll need to re-establish these settings in Azure Update Manager to ensure a smooth transition. Migrating from Automation Update Management to Azure Update Manager is a strategic process that enhances update orchestration capabilities while ensuring compliance and operational efficiency. Let's run through some key steps you should take when making this transition. Firstly, be sure to connect your VMs to Azure Update Manager through the Azure portal, linking them to the appropriate log analytics workspace. This establishes the connectivity needed for tracking compliance and managing updates. This foundational step enables Azure Update Manager to assess the current update state and begin managing patches effectively. Now, leverage Azure Update Manager's enhanced scheduling features to define custom update policies and maintenance windows that align with workload criticality. For critical systems, schedule updates during off-peak hours to minimize impact. Tailor update categories based on business needs, such as prioritizing security updates for production environments. Furthermore, the compliance dashboard can be used to review updated statuses across VMs, identify missed updates, and ensure systems meet compliance standards. Don't forget to set up automated alerts for non-compliant VMs to address any patching failures or delays proactively. Once Azure Update Manager is fully operational, phase out Automation Update Management to prevent duplication and conflicts. Transfer any dependencies or workflows tied to the old system to Azure Update Manager. This step ensures centralized control of updates, reduces errors, and streamlines operational efficiency. Further to the benefits already discussed, Azure Update Manager has several advanced features that can be beneficial, including real-time compliance tracking. This feature gives real-time insights into update statuses with customizable filters that help you focus on critical updates or specific VM groups. It also has automated alerts and notifications. By setting up alerts in Azure Monitor, you can stay informed about critical update failures or changes in compliance status, allowing your team to act promptly. Lastly, you can integrate Azure Policy to ensure compliance across VM environments. This integration allows for automatic enforcement of updated policies, helping maintain alignment with security standards and operational requirements. Now let's explore some key factors to keep in mind when migrating to Azure Update Manager. First, if you're dealing with complex or large environments, it's beneficial to migrate VMs in phases based on workload, priority, or region. This phased approach reduces risk of misconfiguration or downtime, ensuring each group of VMs is stable before moving forward. You should also test the new update configurations on a subset of VMs early to identify and address any configuration or compatibility issues. Lastly, before starting the migration, safeguard your VMs using Azure Backup or similar snapshot protection. This helps ensure recoverability in case of any issues encountered during migration. Let's consider how this migration might work in a real-world scenario. Imagine a financial company, FinTech Solutions, that previously relied on Automation Update Management to manage critical VMs across multiple regions. In this scenario, FinTech's IT team will migrate by, firstly, non-critical VMs are onboarded to Azure Update Manager and their initial compliance is monitored. Then, FinTech will configure custom maintenance windows for production and development environments, mirroring the schedules used in Automation Update Management. And lastly, they will conduct a phased migration by workload type, starting with development VMs and then moving to production VMs. Once stability is confirmed and compliance is verified across all VMs, they will proceed to decommission the Automation Update Management VMs. Migrating from Automation Update Management to Azure Update Manager is essential for leveraging the latest in Azure's update management capabilities. Organizations can ensure a seamless transition by preparing thoroughly, verifying compliance, and following a phased migration process. This migration not only aligns your operations with Azure's latest update management practices, but also simplifies compliance and security for a modernized infrastructure. Congratulations on completing this module. You've made great strides and acquired valuable skills in patching and updating virtual machines. Throughout this module, you explored various advanced topics that empower you to implement effective update management practices in Azure, ensuring security and stability within your virtual environments. Now, let's take a moment to recap the key concepts you've learned, ensuring you're well prepared for the module quiz and ready to apply these skills in real-world scenarios. You started the module by discovering the essential role regular updates play in maintaining security, stability, and performance in Azure virtual machines or VMs. A key focus was on understanding how unpatched VMs are vulnerable to security risks. Through real-world examples, you also learned how outdated systems can become exposed to attacks, which underscored the critical need for timely updates to create a resilient Azure environment. You then reviewed the patching mechanism within Azure, examining how Azure Update Management handles VM updates. You were guided through the tools, settings, and streamlined processes Azure offers to keep your systems current. This overview provided a solid foundation for understanding update management, including real-time tracking and patch deployment. Further readings reinforce the benefits of regular updates, which include enhanced security, performance improvements, and compatibility with new features. They emphasized why proactive update management is crucial. Following this, you gained insights into best practices, configurations, and troubleshooting tips for patching VMs effectively. Configuring automatic updates within Azure was another core topic. Before, a video walked you through scheduling and configuration options to automate update processes smoothly, ensuring your infrastructure remains secure with minimal manual intervention. You also learned about automation tools such as Azure Update Manager, which streamlines update deployment. These tools enable efficient, scalable update management across your VM fleet, helping you save time and effort on routine patching tasks. A section on common issues and errors during patching then provided you with practical guidance on diagnosing and resolving update challenges, which is crucial for maintaining continuous update management. Additionally, you learned about patch management strategies that are tailored for larger environments and covered techniques to manage dependencies, scheduling, and orchestrating patch deployment effectively. This knowledge is essential for handling updates in complex or high-volume VM environments. Further readings highlighted best practices for configuring automatic updates, including scheduling, maintenance windows, and rollback procedures. You also reviewed critical details about update management, such as permissions, data collection frequency, and update classifications, providing a deep understanding of managing updates in Azure. You then followed a practical walkthrough on using Azure Update Manager, covering how to set up daily update assessments, track compliance, and optimize costs. Leveraging Azure Policy and Azure Update Manager, you explored how to establish daily assessments and compliance tracking for both Azure and Arc-enabled machines, enabling you to manage patching proactively and efficiently. Finally, the module included a comprehensive overview of managing updates specifically for Azure VMs. You learned to use Azure Update Manager to track and report patch compliance across your VM environment, which supports assessing your security posture and meeting regulatory requirements. Towards the end of the module, you explored the migration process to Azure Update Manager as automation update management is retired. Through step-by-step guidance, you learned how to configure Update Manager optimally, rounding out your understanding of Azure's update management tools. With the insights gained from the videos, readings, and activities in this module, you're now well prepared to make informed decisions about effective update management in Azure, ensuring security and stability across your virtual environments. As your final step, it's time to take the module quiz. If there are any areas where you feel uncertain, don't hesitate to revisit the videos, readings, or activities to strengthen your understanding. Good luck with the quiz. Compliance in Azure ensures that data is secure, privacy is maintained, and organizations meet the required regulatory standards. This is especially relevant to organizations handling sensitive data or regulated workloads. This video covers Azure's commitment to data protection and the key certifications that help organizations achieve their compliance goals in the cloud. Organizations are responsible for protecting sensitive information and must comply with regulations like GDPR, HIPAA, and PCI DSS to avoid legal issues, protect customer trust, and prevent costly fines. But compliance is not just a legal obligation. It's a security measure that safeguards cloud data and builds trust with users and stakeholders. Microsoft Azure addresses these needs with the comprehensive compliance framework. It helps organizations meet diverse regulatory needs by combining advanced security practices, data privacy features, and broad certification support. For example, Azure offers over 90 compliance certifications that help organizations in various industries such as healthcare, finance, and government to meet their specific regulatory requirements. Global and regional certifications include the following. First is ISO IEC 27001, an international standard for information security management. Second are SOC 1, 2, and 3. These certifications focus on data privacy and processing integrity, which is important for organizations that handle customer data. Third is FedRAMP, which is essential for US federal agencies and ensures that government data in the cloud meets high security and integrity standards. Fourth is GDPR compliance, which covers data privacy standards in the European Union, essential for any organization processing EU citizen data. There are also industry-specific certifications like HIPAA, which is required for handling protected health information in the US, and PCI DSS, necessary for processing credit card transactions securely in the financial sector. These certifications enable organizations to rely on Azure's cloud infrastructure to meet strict industry and regional standards, providing confidence that data is protected and managed appropriately. Azure provides privacy and security controls designed to help organizations maintain compliance with global standards. These controls ensure data privacy through encryption, access controls, and automated monitoring of data flows. For example, organizations can use Azure's encryption capabilities to protect sensitive data in transit and at rest, ensuring it remains private and secure. As you learned before, Azure Policy is essential for managing compliance across a cloud environment. It allows organizations to enforce rules and configurations that help maintain consistent standards. With Azure Policy, users can restrict deployments, enforce tagging, and implement governance requirements to ensure compliance throughout Azure environments. It continuously assesses resources and flags configurations that don't align with defined policies. This proactive approach helps organizations promptly address compliance issues, reducing risks and ensuring that resources remain in alignment with organizational standards. Azure enables consistent compliance monitoring and offers tools to automatically enforce policies across resources. Automated compliance checks help ensure resources consistently meet organizational and regulatory standards. You can use Azure Policy to set up automated checks and notifications for compliance violations, reducing the risk of non-compliance. Azure's Compliance Documentation Portal and Microsoft Trust Center provide valuable resources, including certification reports, audit information, and privacy details that allow organizations to understand and verify Azure's compliance offerings. The portal provides access to reports and documents that demonstrate Azure's regulatory adherence. These resources can be useful for audits and compliance verification. Azure's compliance offerings are continually updated to reflect changing legal and regulatory landscapes, ensuring that organizations remain compliant as new standards emerge. By leveraging Azure's compliance updates, a global organization can ensure its operations in multiple regions align with both local and international regulations, simplifying compliance across borders. Maintaining compliance in Azure not only meets regulatory obligations, but also strengthens trust with customers and partners. Demonstrating regulatory adherence in the cloud builds long-term credibility and reinforces Azure's role as a secure, compliant platform. Overall, Azure's extensive compliance framework helps organizations meet regulatory standards, protect data, and foster trust. With Azure Policy for enforcing governance, continuous monitoring, and accessible documentation, Azure equips organizations with the tools needed for a compliant and secure cloud environment. The Payment Card Industry Data Security Standard, or PCI DSS, is a globally recognized standard designed to secure credit card data and prevent fraud. Developed by major credit card companies, Visa, MasterCard, and American Express, it outlines requirements for organizations that store, process, or transmit cardholder data. Any organization accepting payment cards from the major credit card brands must adhere to PCI DSS standards to protect against fraud. Achieving PCI compliance in Azure requires taking proactive steps to secure your Azure environment. Unlike HIPAA, PCI DSS does not require a specific agreement with Microsoft, but it does require that you configure your Azure resources with security measures that meet PCI standards. So while Azure provides a robust foundation for PCI DSS compliance, it's essential to remember that Azure's compliance certification does not automatically extend to the applications you develop on its platform. However, you can configure several Azure services to help ensure your applications meet PCI DSS requirements. Which ones you configure will depend on your business needs, such as processing online payments or storing customer data. Some of these services include Azure and Azure Government, Microsoft Cloud App Security, Flow as a standalone service or within Office 365 and Dynamics 365 plans, Graph, Intune, Power Apps as a standalone service or within Office 365 and Dynamics 365 plans, Power BI as a standalone service or within Office 365 plans, OneDrive for Business and SharePoint Online in the United States only. When configured appropriately, these services provide a secure infrastructure that helps meet PCI requirements for handling cardholder data safely. Achieving PCI DSS compliance in Azure involves aligning your environment with the requirements set out by the PCI Security Standards Council. The Council publishes helpful resources like the PCI DSS Quick Reference Guide, which explains how to protect cardholder data in a payment card processing environment. In addition to this guide, Microsoft provides a specialized Azure Security and Compliance PCI DSS blueprint. The blueprint offers a practical roadmap with templates, reference architectures, automated scripts, and deployment guidance. It provides the tools and guidance necessary for implementing the PCI DSS framework's 12 primary requirements. These 12 requirements are grouped into 6 security goals. Here's a breakdown of these and how they apply to managing compliance in Azure. The first goal is to build and maintain a secure network and system. Its corresponding 2 requirements are as follows. Requirement 1 requires you to use Azure Firewall and Network Security Groups to establish and maintain firewall configurations that protect cardholder data. This allows you to control and secure traffic flows across your network. Requirement 2 is to replace vendor-supplied defaults for system passwords and other security parameters. To enhance access security, you can implement Microsoft Entra ID to enforce secure password policies and multi-factor authentication. The second security goal is to protect cardholder data. To fulfill this, requirement 3 is to use Azure Key Vault to securely store sensitive cardholder data together with Microsoft Entra ID role-based access control to restrict data access to authorized personnel only. The fourth requirement is to encrypt all cardholder data transmitted across public networks. To do so, you should enable Transport Layer Security or TLS for network communications and configure Azure Storage and SQL Database to ensure encryption at rest and in transit. Goal number 3 is to maintain a vulnerability management program. Requirement 5, falling under this goal, is to implement Microsoft Defender for Cloud to protect systems from malware and keep antivirus software up to date. You can use Defender's built-in threat detection and malware scanning to enable continuous monitoring. Requirement 6 is to develop and maintain secure applications by using Microsoft Defender for Cloud recommendations, conducting regular vulnerability assessments, and continuously patching virtual machines through Azure Automation for security updates. Goal 4 is to implement strong access control measures. Thus, requirement 7 is to restrict access to cardholder data based on business needs using Microsoft Entra ID role-based access control to assign the minimum necessary permissions. Requirement 8 is to ensure users are uniquely identified and authenticated before accessing system components with Entra ID single sign-on or SSO and multi-factor authentication. Requirement 9 is to control physical access to cardholder data by leveraging Microsoft Entra ID RBAC settings to restrict access to sensitive data environments exclusively to authorized personnel. The fifth goal is to regularly monitor and test networks. Therefore, requirement 10 is to track and monitor all access to network resources and cardholder data using Azure Monitor and Microsoft Defender for Cloud Logs, enabling logging for critical resources to maintain audit trails. You should also use Microsoft Sentinel to centralize, analyze, and correlate security event data for advanced threat detection and response. The second last requirement, number 11, is to regularly test security systems and processes by conducting penetration testing and using Microsoft Defender for Cloud to simulate and identify potential security weaknesses. The last goal is to maintain an information security policy and its corresponding requirement is to develop, document, and maintain an organization-wide security policy in Azure Policy. This policy should define information security roles, responsibilities, and practices for all employees. Azure Policy enables you to enforce and audit compliance with this policy throughout the cloud environment. Using these requirements as a foundation, you can establish comprehensive security measures that align with PCI DSS, helping protect your payment processing environment. In conclusion, PCI DSS compliance in Azure requires a combination of secure configurations, proactive monitoring, and adherence to industry standards. By leveraging Azure's built-in tools and PCI DSS blueprint, organizations can implement structured, security-focused practices to protect cardholder data. Following these guidelines not only supports compliance, but also enhances overall data security and builds trust with customers and stakeholders. By now, you should be familiar with the roles that various Azure and Microsoft tools and services play in security monitoring, incident management, and compliance enforcement. This video expands on what you know about those roles and explains how tools and services like Microsoft Defender for Cloud, Azure Monitor, Microsoft Sentinel, and Azure Policy can be used together to provide more advanced continuous compliance monitoring. In doing so, it will become clear how these tools enable proactive identification, tracking, and resolution of compliance gaps to ensure that your Azure environment aligns with regulations. Let's start with Microsoft Defender for Cloud, a cornerstone of compliance monitoring in Azure that offers integrated visibility and actionable insights into your resources' compliance posture. Its regulatory compliance dashboard provides a comprehensive view of your environment's compliance status, mapping your resources to regulatory standards like PCI DSS, GDPR, and ISO 27001. This dashboard can display compliance scores and highlight non-compliant resources for quick resolution. In terms of continuous security assessment, it regularly evaluates resources to identify non-compliant with critical configurations such as encryption, firewalls, and access controls. And it integrates with Azure Policy to enforce remediation automatically. For example, Defender for Cloud can flag unencrypted storage accounts and provide a one-click remediation option to enable encryption. Its actionable recommendations offer step-by-step guidance to resolve compliance gaps, ensuring resources meet organizational and regulatory requirements. For instance, it may provide recommendations for enabling TLS encryption for resources transmitting sensitive data. Furthermore, its integration with other tools like Sentinel means it can escalate compliance violations for incident management and provides data for Azure Monitor dashboards to track compliance trends. Azure Monitor is a key component of Azure's compliance tool arsenal. Although it is mostly known for tracking performance, it plays a significant role in compliance monitoring by providing granular visibility into resource configurations and administrative actions. Let's examine some of its key compliance applications. First, activity logs track administrative activities like user access and resource changes to provide a full audit trail for compliance. For example, it can detect and log unauthorized configuration changes to VMs handling sensitive data. Second, custom compliance metrics enable the tracking of compliance-specific metrics such as the number of encrypted resources or properly tagged virtual machines. For instance, dashboards can display compliance rates for encryption policies across multiple subscriptions. Third, automated alerts allow you to configure alerts for policy violations, and because Azure Monitor integrates with Logic apps, you can also automate remediation. For example, if storage accounts without proper access controls are detected, an alert and automated remediation workflow are triggered. The next tool that offers advanced compliance features is Microsoft Sentinel. You've already learned the basics of Microsoft Sentinel for log collection, detection rules, and security incident management. When it comes to compliance, Sentinel extends these capabilities with advanced analytics and automation. Compliance-specific features of Sentinel include the following. Custom analytics rules allow you to define rules for compliance violations, such as unauthorized changes to tagged resources or attempted access to restricted data. For instance, you can create a rule to detect when resources flagged as non-compliant by Azure Policy are accessed. Audit-ready incident logs retain detailed logs of compliance incidents, simplifying regulatory audits. For example, they automatically generate reports of all compliance-related alerts and their resolutions. And finally, proactive compliance playbooks respond to incidents by, for example, isolating non-compliant VMs. In such a case, you can deploy a playbook to block network traffic for non-compliant VMs until encryption is applied. Another essential tool is Azure Policy Insights, which bridges the gap between enforcement and monitoring. While Azure Policy ensures resources adhere to defined standards, Policy Insights provides real-time monitoring and reporting on compliance status. Azure Policy Insights compliance features include the following: compliance dashboards that visualize compliance rates across policies, subscriptions, and resource groups. A dashboard might show that 95% of storage accounts meet encryption requirements, and then it also gives details of the non-compliant resources. Historical trends and patterns help you to identify recurring issues and improve enforcement strategies. For instance, it may identify a pattern of consistent tagging violations in development environments and therefore recommend pre-deployment validation. Lastly, it offers seamless integration. Alerts from Azure Policy Insights can trigger Microsoft Sentinel incidents or appear in Defender for Cloud's compliance dashboard. Let's go through the steps of an example of unified compliance monitoring in action. With the goal of monitoring PCI DSS compliance, you can use Azure Policy to enforce encryption and tagging requirements on storage accounts. Monitor compliance rates with Policy Insights and flag non-compliance in Defender for Cloud. Escalate repeated violations to Sentinel for incident tracking. And automate remediation using Sentinel playbooks and logic apps. Another scenario is when you're monitoring your organization for GDPR data residency compliance. You would use Azure Monitor to log and track cross-region data transfers. Enable Defender for Cloud to flag data residency violations in real time. And leverage Sentinel to detect and respond to unauthorized data movements. Overall, there are several best practices you should enforce for compliance monitoring using the tools we discussed. You should enable cross-tool integration by combining Defender for Cloud, Sentinel, and Azure Policy to create a unified compliance monitoring strategy. It's a good idea to automate compliance workflows by using Sentinel playbooks and Azure Monitor alerts with logic apps to respond to incidents immediately. A good habit to maintain is to periodically review compliance dashboards in Defender for Cloud and Policy Insights to address trends proactively. Lastly, you should maintain logs for audits by using Microsoft Sentinel and Azure Monitor for long-term log retention to simplify audit processes. In summary, Azure compliance monitoring tools work together to provide a comprehensive framework for maintaining compliance. By integrating continuous assessments, automated alerts, and actionable remediation steps, these tools ensure your Azure environment remains secure and aligned with regulatory requirements. By now, you've developed a solid understanding of how Azure's compliance tools help enforce and monitor compliance across your organization. Another key component to this is auditing, which is a critical process that goes beyond simple checks. It provides a structured, in-depth evaluation of your compliance landscape. Auditing can be imagined as a thorough health checkup for your compliance environment. It confirms your position and identifies potential vulnerabilities, helping your organization stay ahead of changing regulatory standards. In this video, you'll explore strategic approaches for conducting audits within Azure. By leveraging advanced frameworks and methodologies, you'll learn how to uncover compliance gaps, track emerging trends, and ensure your organization is fully prepared to meet evolving compliance demands. These insights will empower you to proactively enhance your compliance readiness and maintain a robust, adaptable compliance posture in the cloud. Let's begin by exploring how auditing plays a crucial role in the compliance lifecycle. Unlike monitoring, which continuously tracks compliance status, auditing provides a structured review of past actions and configurations. Effective auditing ensures that enforced policies like encryption mandates or tagging requirements are working as intended. It also identifies recurring compliance issues over time and provides data-driven insights for improvement. And it helps organizations maintain a clear, documented compliance posture for external regulatory reviews. Auditing should also encompass these essential components. Start by defining the audit objectives, which involves identifying the regulatory standards to be audited, such as HIPAA or PCI DSS, along with the specific compliance controls that need assessment. Next, you need to schedule periodic audits, such as monthly or quarterly. This ensures ongoing compliance rather than reactive fixes. Lastly, predefined templates in Compliance Manager and Azure Policy should be used to streamline audit preparations for specific standards. Another important step is to categorize your resources, including grouping your resources according to regulatory requirements, such as resources handling patient data for HIPAA, and apply audit-specific tagging for resources. This makes it easier to filter and analyze audit logs. Now let's explore several strategic approaches to enhance the effectiveness of your audits. Firstly, before conducting your audit, you should configure all resources with audit-friendly settings such as encryption and tagging policies to ensure compliance. Furthermore, templates like Azure Security and Compliance Blueprints can be used to create audit-ready architectures. Next, a unified log analytics workspace can consolidate logs from tools like Azure Monitor, Sentinel, and Defender for Cloud. You should ensure these logs are retained for the minimum period required by regulatory standards. Additionally, while you're conducting the audit, you should prioritize high-risk resources, focusing on those storing sensitive data or exposed to public networks. Leverage Azure Policy to maintain consistent configurations across these resources. Also, ensure you examine compliance dashboards in Defender for Cloud to identify any non-compliance issues. Cross-reference findings with Sentinel logs to detect anomalies or unauthorized activities. After completing the audit, take the following actions. Use Sentinel to monitor for recurring incidents like untagged resources or unauthorized access attempts, and assign responsibilities for addressing issues found in the audit. Use Azure Policy and Logic apps to automate remediation processes for ongoing compliance. Before we wrap up, let's explore how an audit would look in a real-world scenario. Let's imagine a healthcare provider, MediHealth Solutions, needing to ensure HIPAA compliance within its Azure environment. Their audit objective is clear: verify that encryption, access controls, and logging for electronic protected health information, or EPHI, meet compliance requirements while stored and processed in Azure. This focus helps MediHealth Solutions maintain the security and privacy of sensitive data while meeting regulatory standards. MediHealth approaches the audit by using Defender for Cloud's HIPAA compliance dashboard to identify any resources that don't meet HIPAA standards. They also check encryption settings for storage accounts and SQL databases through Azure Policy Compliance reports, ensuring that all sensitive data is properly secured. They then monitor access to EPHI. They use Azure Monitor's activity logs and correlate this data with Sentinel, enabling incident tracking and detecting unauthorized access attempts. Through this approach, MediHealth Solutions generates a clear and actionable audit report that highlights any gaps, lists remediation steps, and identifies trends for continuous improvement. As you've witnessed, auditing is a cornerstone of effective compliance management. It offers a structured approach to validating policies, analyzing trends, and preparing for regulatory evaluations. By leveraging strategic auditing practices, organizations can achieve robust compliance in dynamic cloud environments. A strong backup strategy is not only a safeguard against data loss, but a critical component of ensuring business continuity in dynamic cloud environments. This video builds on your foundational knowledge of Azure Backups, focusing on strategic planning tailored to organizational needs. Backup strategies matter because they ensure business continuity by recovering critical data quickly, thus enabling operations to resume with minimal downtime. They also ensure data integrity by protecting sensitive and operational data from corruption, deletion, or cyber threats. And they ensure regulatory compliance since backup strategies are designed to align with standards like ISO 27001, GDPR, or HIPAA by meeting data retention and recovery requirements. Without a well-structured backup strategy, data recovery times can extend beyond acceptable limits. Recovery operations may fail due to inconsistencies or missing backups. And costs can spiral without clear guidelines for storage and retention. When planning backups, two critical metrics guide decision-making: recovery point objective and recovery time objective. Recovery point objective refers to the maximum amount of data that can be lost during an incident. It defines how far back in time you need to recover your data to resume operations. Lower RPOs require more frequent backups, increasing costs but minimizing data loss. Here are two examples. For an e-commerce platform processing thousands of transactions per minute, an RPO of 5 minutes ensures that only a few transactions are lost in case of an outage. While for a document archive system, an RPO of 24 hours may suffice as the data changes less frequently. Recovery time objective, on the other hand, specifies the maximum amount of time a system or application can remain unavailable before it affects business operations. In other words, it determines how quickly you need to restore services after a failure. Lower RTOs demand faster recovery methods and potentially higher infrastructure investments. For instance, a mission-critical database with an RTO of 15 minutes may require high-performance storage and automated recovery workflows, while a development environment with an RTO of 24 hours allows more flexibility in restoration methods. Understanding these metrics ensures alignment between business priorities and backup strategies while optimizing costs. Now let's go through the steps to develop a robust backup strategy. Step 1 is to classify data and workloads. Not all data has equal importance, so you should prioritize workloads based on their criticality. Examples of high-priority workloads are transactional databases or customer records. These would require frequent backups, like every 5 minutes, to meet low RPOs. A moderate priority example is internal collaboration tools. Here you could use daily or weekly backups. Archived logs or static content are low priority, so monthly backups stored in cost-effective archival tiers make the most sense. Step 2 is to select your backup frequency, which would depend on data sensitivity, as more sensitive data requires more frequent backups, as well as workload type. Dynamic workloads need frequent backups, while static workloads may need fewer. For instance, a customer database updated every minute needs at least hourly backups to align with an RPO of less than 1 hour. Meanwhile, a content library updated weekly might require only weekly backups. The third step is to define storage locations. Azure offers multiple storage tiers to balance performance and costs. The hot tier is ideal for frequently accessed backups, like snapshots of critical transactional databases. The cool tier works best for backups accessed less frequently, but that have to be retained for 30 days or longer. For example, it can be used for weekly backups of moderately critical applications. Lastly, the archive tier is for long-term storage, like for compliance backups with retention periods of several years. As you know by now, a crucial aspect of any backup strategy is to enable automation. You're familiar with tools like Azure Backup, Azure Policy, and Logic Apps. Azure Backup automates backups for VMs, databases, and file shares, and enables point-in-time recovery and long-term retention policies. Policy ensures compliance by enforcing backup tagging and configurations, while Logic Apps automates workflows for backup-related notifications and remediation. For instance, administrators can automate a workflow to alert them when backup storage usage exceeds 80% capacity. Let's examine a scenario where you have to develop a backup strategy for a healthcare system. A healthcare provider processes sensitive patient data and requires robust backups to meet HIPAA compliance. The provider must ensure minimal data loss for patient records and recover systems quickly in case of failures. So the backup plan for critical systems like electronic health records would specify hot tier storage for quick recovery and incremental backups every 50 minutes. For archival data like old patient files, monthly backups stored in the archive tier would work best. This plan minimizes downtime, protects sensitive data, and meets compliance requirements. By leveraging Azure's tools and understanding key metrics like RPO and RTO, you can create a robust plan that protects critical data, meets compliance requirements, and aligns with organizational priorities. Ultimately, developing an effective backup strategy requires a thoughtful approach to data classification, backup frequency, and recovery goals. As you deepen your understanding of Azure's disaster recovery capabilities, it's essential to focus on the strategic role of Azure Site Recovery, or ASR. While backup strategies ensure data availability, ASR provides a higher level of resilience by enabling automatic failover and failback during outages. This ensures critical workloads remain operational with minimal downtime, supporting business continuity across diverse scenarios. Azure Site Recovery is a disaster recovery as a service, or DRaaS solution that enables business continuity. It ensures critical workloads remain operational during outages by replicating data and services to a secondary Azure region. It also reduces manual intervention by automating the switch to the backup region, in other words, the failover, and the switch back to the primary region, the failback. ASR also offers cost-effective resilience by leveraging Azure's global infrastructure without maintaining expensive on-premises disaster recovery setups. Let's go through some of its key benefits. Azure Site Recovery replicates workloads across Azure regions to mitigate regional failures. It captures consistent recovery points for interdependent workloads like multi-tier applications. And it enables organizations to tailor replication and recovery policies to their specific needs. Furthermore, ASR ensures that your environment is always prepared for unexpected outages by continuously replicating data to a targeted region. This proactive approach reduces recovery times. In other words, you have a lower RTO. And it minimizes data loss by maintaining up-to-date recovery points. In other words, a lower RPO. Azure Backup is designed to ensure data recovery, and ASR complements this by enabling full system recovery. Together, they create a comprehensive business continuity framework. Azure Backup focuses on long-term data retention and recovery from data corruption or accidental deletion, while ASR focuses on short-term operational continuity during outages. Lastly, for industries governed by regulatory frameworks, ASR supports compliance by ensuring systems remain operational during disasters and enabling rapid recovery within specified timeframes. Now let's examine some of Azure Site Recovery's essential features. ASR replicates workloads in near real time to a secondary region, ensuring minimal data loss during failover scenarios. This is crucial for workloads like financial transactions or healthcare applications, where even minor data loss can have significant impacts. Azure Site Recovery also ensures consistency across related VMs running interdependent workloads, such as application servers, where it maintains data consistency between application servers and their associated databases, and web applications, where it coordinates failover for all components of a multi-tier web application. Additionally, ASR generates recovery points that you can use to restore workloads. These include crash-consistent snapshots that reflect the state of the data at a specific moment but may not capture in-progress transactions, and application-consistent snapshots that capture the full state of applications, including in-progress transactions and memory states, ensuring reliable recovery for critical systems. Lastly, Azure Site Recovery automates complex disaster recovery processes through failover, where it automatically switches workloads to the target region, and failback, where it restores workloads to the primary region once the outage is resolved. Let's explore a scenario of how an organization can leverage ASR for disaster recovery. A global retail company needs to ensure its online store remains operational during regional outages. The store consists of a web front end, a back-end application server, and a transactional database. To achieve continuous business operations, the company strategically employs Azure Site Recovery. Its replication policies are designed for continuous replication of all components to a secondary Azure region, using application-consistent snapshots to prevent data loss during failover. The failover plan orchestrates a sequence in which the database is activated first, followed by the application server, and finally the web front end. This approach minimizes disruption to the online store, helping maintain customer trust and ensure continuous operations. In summary, Azure Site Recovery is the cornerstone of disaster recovery planning in Azure, enabling organizations to proactively prepare for outages, maintain operational continuity, and meet regulatory requirements. ASR ensures your Azure workloads remain resilient in even the most challenging scenarios. Congratulations on completing the Azure Cloud Compliance, Backup, and Disaster Recovery module. You've made significant progress in mastering key strategies for maintaining compliance, monitoring resources, and implementing disaster recovery solutions within Azure. After completing this module, you should now be able to discuss the importance of compliance in Azure, describe strategies for auditing Azure resources to ensure compliance, and develop effective backup and disaster recovery strategies. Before you proceed to the module quiz, let's review the essential points to confirm you're well prepared. You began by exploring Azure Cloud Compliance and the critical role it plays in meeting regulatory standards across different industries. This introduction highlighted the significance of compliance in the cloud environment and the potential consequences of non-compliance. You learned about the importance of following regulatory requirements to protect data, secure resources, and meet industry standards. Moving forward, you delved into specific regulatory frameworks like PCI DSS. Here you examined how PCI DSS principles are applied within Azure and identified key Azure services that support these compliance requirements. Through this lesson, you gained insight into configuring Azure resources to align with PCI DSS standards, emphasizing best practices for safeguarding payment card information. Next, you reviewed the tools Azure provides for monitoring and auditing compliance. In this section, you explored essential tools like Microsoft Defender for Cloud and Azure Policy Insights. You learned how these tools help monitor compliance, detect potential security risks, and support proactive management of compliance across resources. Following this, you covered effective auditing strategies in compliance management. This lesson focused on methods for conducting audits and using Azure's capabilities to verify compliance. You reviewed best practices in monitoring, including setting alerts, continuous monitoring techniques, and case studies showcasing successful compliance management. By studying these approaches, you gained practical insights into maintaining a robust compliance framework. After mastering compliance monitoring, the module transitioned to backup strategies and disaster recovery. You examined the importance of creating reliable backup plans, including considerations for data types, backup frequency, and storage options. In particular, you explored how Azure's backup solutions can help you manage data effectively, safeguard against data loss, and improve recovery times. Finally, the module introduced you to Azure Site Recovery, a critical tool for implementing disaster recovery. Through this lesson, you learned about the features of Azure Site Recovery, the process of setting it up, and the benefits of using it to support business continuity. You also studied the steps involved in developing a comprehensive disaster recovery plan, including guidelines for defining recovery objectives, establishing backup schedules, and configuring replication and failover procedures. By the end of this module, you're equipped with a strong foundation in Azure compliance, backup strategies, and disaster recovery planning. You've built a skill set that ensures regulatory adherence, data protection, and resilience against potential disruptions. The last step is to complete the module quiz. If you feel there are areas that need further review, revisit the relevant videos, readings, or activities to reinforce your understanding. Best of luck with the quiz. Congratulations on completing the Azure Backup Security and Compliance Administration course. This course was meticulously designed to equip you with the essential skills to manage data backup, implement robust security controls, and ensure compliance within Azure. After completing the final activity and graded quiz, you will be prepared to develop strategic backup plans, configure security measures to protect data, and maintain compliance with industry standards, all foundational skills for administering a secure and resilient Azure environment. This recap reviews each module, helping you consolidate your knowledge and identify areas for further review before the final assessments. The course began with an introduction to Azure Backup Strategies, where you explored the strategic importance of maintaining reliable backups to protect data against unexpected loss. You started by examining key types of backup solutions, such as Azure Backup for virtual machines and file shares. This helped you understand the process for configuring backup policies based on data types and recovery objectives. For example, you learned about different backup strategies like full, incremental, differential, and offsite backups. This was followed by a lesson on optimizing file and folder backup configuration, where you investigated best practices for structuring backups to ensure robust data management and protection. You gained skills in designing an effective folder backup system tailored to organizational needs, ensuring that important data is consistently protected without excessive resource usage. Finally, you focused on strategies for backing up virtual machines in Azure, a critical aspect of maintaining data integrity and supporting disaster recovery. By the end of this module, you were equipped to design effective backup strategies, ensuring data resilience and quick recovery in case of data loss. Next, you examined effective update management in Azure to enhance the security and stability of your virtual environments. You learned the importance of regular patching and how to set up automatic updates to streamline the process. In the first lesson, you analyzed the foundational concepts behind patching and updating in Azure. This included an overview of the patching process and tools like Azure Update Manager. Just one of the topics you covered was how Update Manager streamlines the patching process to maintain a secure and resilient Azure environment. Furthermore, you became familiar with configuring automatic updates for Azure virtual machines with a comprehensive guide on settings, scheduling options, and considerations for setting up automated updates. For instance, you learned about how to manage operating system updates across virtual machines in Azure, as well as physical and virtual machines in on-premises, hybrid, and other cloud environments. In Lesson 3, you concentrated on managing patching policies using Azure Update Manager, which involved configuring update assessments, compliance tracking, and patch compliance reporting. A key topic was how to leverage Azure Policy and Update Manager to automate daily assessments and manage compliance, ultimately enhancing patch management. By the end of Module 2, you were well prepared to describe optimal update management practices in Azure. The third module provided a review of strategies for ensuring compliance, monitoring resources, and implementing disaster recovery solutions in Azure. Lesson 1 highlighted the importance of aligning your Azure configurations with industry standards and regulatory frameworks. You gained insight into configuring Azure resources to meet compliance requirements, specifically focusing on PCI DSS standards for handling payment card information securely. Additionally, you discovered Azure monitoring tools such as Microsoft Defender for Cloud and Azure Policy Insights, learning how they contribute to proactive compliance monitoring. Following this, you learned about disaster recovery planning with an emphasis on developing reliable backup strategies. This lesson began with an overview of backup strategies in Azure. You explored considerations such as data types, backup frequency, and storage options to ensure business continuity. You then covered Azure Site Recovery, a key tool for disaster recovery, learning how to set up virtual machine replication and failover to minimize downtime in the event of disruptions. This module increased your proficiency in implementing compliance policies, monitoring resources, and designing backup and recovery solutions. The course culminates in a final activity where you'll apply your skills in configuring Azure monitoring, backup, and disaster recovery tools. In this project, you'll ensure continuous monitoring and auditing of a simulated Azure environment for compliance with a specified architecture. This capstone activity allows you to demonstrate your skills in Azure Backup, monitoring, and disaster recovery, showcasing your ability to uphold compliance and secure Azure resources effectively. To wrap up, the course includes a final graded quiz that will assess your understanding of all the major concepts covered. This assessment ensures you're well prepared to apply your newly acquired knowledge and skills. With this solid foundation, you're ready to take on the AZ900 exam preparation module that follows. As you ready yourself for these final challenges, it's important to revisit any topics you feel less confident in to reinforce your understanding. Good luck and congratulations again on reaching this important milestone in your learning journey. Congratulations! You've shown remarkable dedication and effort and made it to the end of the course. You've mastered crucial skills and concepts related to Azure backup strategies, security protocols, and compliance administration, demonstrating that you have what it takes to configure Azure services and tools for robust and secure backups and disaster recovery plans that comply with regulations. You're now able to implement effective backup strategies for files, folders, and virtual machines, configure automatic VM updates, enforce compliance policies, monitor Azure resources, and develop robust backup and disaster recovery plans with Azure services like Azure Site Recovery. By completing this course, you have a good grasp of configuring file, folder, and virtual machine backups. But that's not all. You've also gained valuable insight into patching and updating virtual machines, configuring automatic updates, and managing patching policies using Azure Update Manager. And let's not forget compliance, backup, and disaster recovery. You now know how to design compliance policies, monitor and audit for compliance, and plan for disaster recovery using Azure Site Recovery. And you applied what you learned by designing the configuration of Azure monitoring, backup, and disaster recovery tools to ensure continuous monitoring and auditing of Azure resources for compliance. Think about everything you can do with this newfound knowledge and skills. You're very close to successfully completing all of the courses in the Microsoft Cloud Support Associate Professional Certificate, which means that as soon as you have completed the exam preparation module, you will receive a professional Coursera certification. This certification is recognized globally, enhancing your credibility and marketability to potential employers. It also serves as proof of your job readiness and can be shared with your professional network. And it demonstrates your commitment to continuous learning and professional development. The certification can benefit you if you're seeking an entry-level position in cloud support, so well done on taking the first steps toward your future career. Completing the program also serves as an essential stepping stone in your preparation for the Microsoft AZ900 exam, which you will continue in the next module. Passing this exam will earn you the Microsoft Azure Fundamental Certification, a common starting point in a journey towards a career in Azure. This certification requires you to demonstrate foundational knowledge of Microsoft Azure architectural components and services, including compute, networking, and storage. You should also know about the features and tools to secure, govern, and administer Azure. Achieving the Microsoft Azure Fundamental Certification validates your understanding of essential cloud concepts, Azure architecture and services, and Azure management and governance. In summary, this course has enhanced your knowledge and skills in Azure Backup, security and compliance, and helped you prepare for the AZ900 exam. It takes perseverance to complete a whole program, and you've done a great job so far. You should be proud of your progress and achievement. The experience you gained will show potential employers that you're motivated, capable, and not afraid to learn new things. Thank you for your hard work and good luck with the rest of your learning journey. With just about any exam, success relies heavily on being prepared. However, there are always other steps you can take to improve your performance and maximize your odds of success. In this video, you'll familiarize yourself with strategies for ensuring your readiness for the AZ900 exam, Microsoft Azure Fundamentals. First things first, let's go over some best practices that are applicable in most assessment scenarios. When test day arrives, consider doing the following. Ensure that you show up well-rested and nourished. Eat a healthy meal or a snack beforehand, and don't drink too much water, as bathroom breaks are not allowed during the exam. You should also give yourself enough time to get set up, as the last thing you want is to feel hurried or be late for the exam. And don't forget to review relevant learning material prior to test day. Space out your study sessions across several days rather than saving everything for the night before. You'll have the option of taking the exam in person at a Pearson VUE test center or online from your home or office. You'll learn more about the particulars a bit later, but should you intend to go the online route, it's important to first verify the following. Make sure that you have a consistent, reliable internet connection that is fast enough to handle video streaming. Also, check that the device on which you'll be taking the test is functioning properly. This includes the microphone and camera, whether you're using a webcam or the hardware built into your computer or mobile device. Your intended testing environment should be quiet and free of distractions for the duration of the exam, so silence your devices and notify others not to disturb you during your testing session. And remember to bring your current government-issued ID, which must be an exact match to the name on your Microsoft certification profile. You'll use your mobile phone to capture the required headshot and ID. So now that you know how to prepare for the exam, let's explore strategies to help you perform your best when it's time to take it. Keep calm and read the question in its entirety before checking the answer options. Students often choose the wrong option because they have misread the question. If there are multiple answer options, try to eliminate answers you know are 100% incorrect. By using this process of elimination, you can cross off all the incorrect answers. Make sure to read every answer option before choosing a final answer. A common mistake that students make is to rush and pick that first answer. If you're having difficulty with the question, move on and come back after you have answered all of the questions you know. Don't forget about time management. Try not to spend too much time on a single question, as this may leave you short on time for the rest. Leave enough time to attempt all the questions before checking them at the end. Depending on the question format, you may not be able to change your answer, so make sure that you have answered them correctly. During your review, you may be tempted to second-guess yourself at times and change your answer. While this can work in certain circumstances, it can also be counterproductive. Remember that every step of your learning journey has been preparing you for the AZ900 exam. Be careful, but try to trust your instincts. Finally, note that the AZ900 exam does not employ negative marking. This means that no points are deducted for incorrect answers. If you're unsure of a question, give your best educated guess. Be aware that some questions will apply partial marking if there's more than one correct answer required. In this video, you discovered several strategies for increasing your chances of passing the AZ900 exam successfully. By implementing them, you'll put yourself on a much more reliable path toward obtaining certification. Previously, you were given information to help set your expectations for the AZ900 exam, Microsoft Azure Fundamentals, and to ensure that you're as prepared as possible come exam day. The topics covered include general exam preparation tips and strategies, the steps to register for and schedule the proctored exam, details on how the exam is administered, a breakdown of the specific skills measured in the exam, readiness strategies specific to the AZ900 exam, including a list of relevant materials to consult with, and links to helpful online resources. In this video, you'll shift your focus to unpacking the exam itself, which includes knowing the format, question types, and other expectations to be aware of. But before you take on the actual exam, you'll be given the opportunity to complete a mock version, which covers the same key skills measured in the proctored exam. So let's start with an overview of the mock exam to highlight what you can gain by completing it. The mock exam is a culmination of everything you learned about throughout the Microsoft Cloud Support Associate Professional Certificate Program. It focuses on your ability to describe cloud concepts, Azure architecture and services, and Azure management and governance. You covered these skills throughout this program and applied what you learned through a mix of knowledge checks, graded assignments, and exercises based on real-world business scenarios. The mock exam is based on a similar style and format as the actual AZ900 exam. It is intended to provide an overview of the style, wording, and difficulty of the questions that you're likely to experience on this exam. However, bear in mind that these questions are not the same as what you will find on the proctored exam, nor does it match its length or complexity. For example, in addition to multiple choice questions, you may encounter additional question types such as drag and drop, build list order, case studies, exhibit, drop-down menus and option boxes, and complete the statement. For the mock exam, you can review the content from the program courses as needed, but this should serve to help you identify knowledge gaps rather than serve as an aid. The AZ900 is a closed book exam, meaning that you cannot bring any study or exam materials into the examination with you. A score of 700 or greater is required to pass. To protect exam security, Microsoft does not specify exam formats or question types before the exam. Microsoft continually introduces innovative testing technologies and question types and reserves the right to incorporate either into exams at any time without advance notice. In this video, you learned about key details of the AZ900 exam, as well as how the mock exam can get you better prepared and increase your odds of success. You now know what to expect, and it's up to you to deliver your best effort. Good luck.
Whether you're a seasoned cloud support professional or just starting out, understanding how to craft effective search prompts can dramatically streamline your troubleshooting process. In this video, you'll explore the powerful combination of Azure's cloud capabilities and Bing Copilot's advanced search prompts. Let's start by understanding what Bing Copilot prompts are. Prompts are instructions or questions that you provide Copilot to generate the desired output. Copilot prompts include 4 parts. First, there's the goal. What do you want to achieve? Next, there's context. What's the situation? Then there are expectations. What do you hope to find? And finally, the source. Where should you find this information? You can put a little or a lot into a prompt, but all that's required is a clear goal. If you want to be more specific, add the other parts. You'll often need to include more than a goal to get the desired results. So why use prompts? There are many benefits to using Bing Copilot prompts in your work. Let's explore them in more detail. The first benefit is efficiency. In crafting precise prompts, you guide Bing Copilot to search for relevant solutions efficiently. Next, there's accuracy. Clear prompts lead to accurate results, saving time and effort. And finally, a comprehensive search involves Bing Copilot examining a wide range of resources, including documentation, forums, and official Microsoft channels. Crafting effective prompts is an art. Let's explore how to do it right. Alice, a skilled IT specialist, receives a vague message from her colleague Bob. Azure issue. Knowing the importance of specifics, Alice sets out to create a clear, actionable prompt. The first step is to be specific. Alice knows that general descriptions are unhelpful. After careful observation of the notification area of Azure Portal, while trying to configure network settings, she finds the exact error. Error 404, resource not found. Noting that she is using an Azure Resource Manager, or ARM, template to deploy the virtual machine, or VM, she refines Bob's message to Error 404, resource not found during virtual machine deployment using ARM template. The next step is to include keywords. To enhance clarity, Alice adds that she is using an ARM template to deploy the VM. So, she refines the prompt further. Error 404 resource not found during virtual machine deployment using ARM template while configuring network settings. It's also important to provide context. Alice briefly describes the broader scenario, providing additional context to better understand the problem. She adds to the prompt, in a multi-region setup facing latency issues. Combining all of these elements, Alice's final prompt might look like this. In a multi-region setup, facing error 404 resource not found during virtual machine deployment using ARM template while configuring network settings. Now, let's walk through the steps to access Bing Copilot. First, in your Microsoft Edge web browser, navigate to https://www.bing.com/chat. You can now log in using any Microsoft account, including a live.com account, hotmail.com account, outlook.com account, or a Microsoft 365 account. After you have logged in, follow any additional prompts to complete the sign-in process. You are now ready to start using Bing Copilot to assist you with your queries and tasks. So, you've successfully logged into Bing Copilot. Now it's time to dive into some real-world, role-focused Azure subscription use cases, starting with Azure Subscription Management. You are a cloud support engineer at a mid-sized tech company that heavily relies on Azure for its cloud infrastructure. Recently, your company has expanded, resulting in multiple Azure subscriptions across various departments. Each department has its own budget, and it's crucial to manage these costs effectively to avoid going over budget. Your task is to set up a system to track usage and costs for those subscriptions, ensuring timely alerts and detailed usage reports for each department. As a cloud support engineer, your role involves managing the cloud infrastructure, optimizing resource usage, and ensuring cost efficiency. Let's examine how you can achieve this using Bing Copilot. First, the goal. What do you want to achieve? You want to track the usage and costs associated with multiple Azure subscriptions effectively. Next is the context. What's the situation? The company is managing multiple Azure subscriptions across different departments, and there is a need to monitor these subscriptions to avoid budget overruns. Now, our expectations. What do you hope to find? You expect to find clear steps to set up cost alerts and usage reports for multiple Azure subscriptions. And finally, the source. Where should you look for this information? You should refer to the Azure Cost Management documentation for accurate and detailed guidance. Using the goal, context, expectations, and source, you can construct the following example prompt. How to track usage and costs for multiple Azure subscriptions. Provide steps to set up cost alerts and usage reports. Reference Azure Cost Management documentation. After successfully setting up cost tracking and alerts for multiple Azure subscriptions, the next challenge is to manage user permissions within these subscriptions. Each department requires different levels of access based on their roles and responsibilities. It's essential to ensure that users have the appropriate permissions to perform their tasks without compromising security. As a cloud support engineer, your responsibility now extends to managing and assigning roles to users within each Azure subscription to ensure proper access control. Your task is to implement a robust role-based access control, or RBAC system, that aligns with the company's security policies and operational needs. Remember, you need the goal, context, expectations, and source. First, the goal. What do you want to achieve? You want to manage user permissions within an Azure subscription effectively. Now, the context. What's the situation? Ensuring appropriate access control for users across various departments within the company. Next are our expectations. What do you hope to find? You expect to find clear steps to assign roles and manage access for users. And finally, the source. where should you look for this information? You should refer to the Azure RBAC documentation for accurate and detailed guidance. Using the goal, context, expectations, and source, you can construct the following example prompt. How to manage user permissions within an Azure subscription. Provide steps to assign roles and manage access. Reference Azure RBAC documentation. After successfully managing costs and user permissions for multiple Azure subscriptions, your next challenge is to address performance issues in Azure Virtual Machines, or VMs. Ensuring optimal performance of VMs is crucial for maintaining the efficiency and reliability of applications running in the cloud. Recently, some departments have reported performance issues with their Azure VMs, specifically experiencing high CPU and memory usage. These performance issues are affecting the productivity of the teams relying on these VMs for critical tasks. Your task is to troubleshoot those performance issues, identify the root causes, and implement optimization strategies to improve the performance of the affected VMs. As a cloud support engineer, your responsibility now includes diagnosing and resolving performance issues in Azure VMs. You need to use Azure's diagnostic tools and best practices to identify and mitigate the causes of high CPU and memory usage, ensuring the VMs run efficiently. Remember, you need the goal, context, expectations, and source. First, the goal. What do you want to achieve? You want to troubleshoot and resolve performance issues in an Azure VM. Next, the context. What's the situation? The VM is experiencing high CPU and memory usage, impacting its performance. And now, our expectations. What do you hope to find? You expect to find diagnostic steps and optimization tips to resolve the performance issues. And finally, the source. Where should you look for this information? You should refer to the Azure VM performance documentation for accurate and detailed guidance. Using the goal, context, expectations, and source, you can construct the following example prompt. How to troubleshoot performance issues in an Azure VM experiencing high CPU and memory usage. Provide diagnostic steps and optimization tips. Reference Azure VM performance documentation. In this video, you learned how leveraging Bing Copilot prompts can significantly enhance your efficiency and accuracy in troubleshooting Azure resources. By crafting well-defined prompts that include clear goals, relevant context, specific expectations, and credible sources, you can streamline the process of finding solutions to common Azure issues. Using Bing Copilot can make your workday so much smoother. It's time to take a deep dive into its knowledge search capabilities to learn more. Imagine using Bing Copilot to create smart prompts for cost optimization by tapping into Azure Cost Management's powerful features. In this video, you'll explore some great strategies to help you streamline your cost optimization processes and get the most out of your cloud investment. Let's dive into some real-world use cases and see how it all works. Building on your efforts to manage costs, user permissions, and virtual machine or VM performance, the focus now shifts to cost optimization within Azure. Cost optimization is crucial for ensuring that the company's cloud expenditure is efficient and sustainable. In your role as a cloud support engineer, during a quarterly review of Azure expenditures, you notice a sudden and unexplained spike in costs. To maintain budgetary control and optimize spending, you need to investigate the cause of this increase and identify any anomalies in the cost trends. You will use Azure's cost management tools to generate reports, analyze data, and recommend optimization strategies. Remember, you need the goal, context, expectations, and source. First, the goal. What do you want to achieve? You want to analyze cost trends to identify unusual spikes in Azure spending. Next is the context. What's the situation? conducting a quarterly review and noticing a sudden spike in Azure costs. Then come your expectations. What do you hope to find? Steps to generate cost trend reports and identify anomalies. And finally, the source. Where can you find this information? You should refer to the Azure Cost Management documentation for accurate and detailed guidance. Using the goal, context, expectations, and source, you can construct the following example prompt. How to analyze cost trends to identify unusual spikes in Azure spending. Provide steps to generate cost trend reports and identify anomalies. Reference Azure Cost Management documentation. As part of our ongoing efforts to optimize Azure costs, you need to focus on identifying and managing underutilized resources. This step is crucial for eliminating waste and ensuring that the company's cloud expenditure remains efficient. As a cloud support engineer, your role involves conducting regular reviews of resource use to identify and manage underutilized resources. This helps to ensure that the company's cloud environment is cost-effective and optimized. Let's start again with the goal. What do you want to achieve? You want to identify underutilized resources within Azure. Then, let's examine the context. What's the situation? Conducting a monthly resource utilization review. Next, our expectations. What do you hope to find? Steps to find and manage underutilized resources. And finally, the source. Where should you look for this information? You should refer to the Azure Resource Optimization documentation for accurate and detailed guidance. Using the goal, context, expectations, and source, you can construct the following example prompt. How to identify underutilized resources in Azure. Provide steps for finding and managing underutilized resources. Reference Azure Resource Optimization documentation. Building on your efforts to optimize Azure costs, manage user permissions, address VM performance issues, and identify underutilized resources, your next focus is on finding the most cost-effective regions to distribute workloads. This step is essential for maximizing savings and ensuring efficient resource allocation. As a cloud support engineer, your role now involves exploring various Azure regions to find the most cost-effective options for workload distribution. You will use Azure's regional pricing information to make informed decisions and implement strategies for moving workloads. Just as before, you need the goal, context, expectations, and source. By now, you realize that the goal defines what you want to achieve. In this case, you want to explore cost-effective regions for distributing Azure workloads. And what about the context? What's the situation? Planning workload distribution across different Azure regions. Next up, our expectations. What do you hope to find? A list of cost-effective regions and steps to move workloads there. And lastly, the source. Where should you look for this information? You should refer to the Azure Regional Pricing documentation for accurate and detailed guidance. Using the goal, context, expectations, and source, you can construct the following example prompt. How to explore cost-effective regions for Azure workloads. Provide a list of cost-effective regions and steps to move workloads. Reference Azure Regional Pricing documentation. You now have some handy strategies to optimize your Azure cloud expenses. Using Bing Copilot prompts, you'll be able to quickly spot cost-saving opportunities, better manage resources, and keep your cloud spending in check. It's all about making your work life easier with the power of generative AI. Imagine you're an Azure architect or cloud solutions designer given the complex task of designing and deploying robust and scalable Azure architectures. You could do with a dependable ally to help you navigate all the intricacies that this entails. Well, there's no need to worry, as Bing Copilot can help streamline this process. In this video, You'll examine the concept of using Bing Copilot prompts to enhance your Azure architecture development experience. You'll explore the benefits of these prompts, strategies for crafting them effectively, and see examples of prompts for common Azure architecture scenarios. Let's dive into some example prompts for common Azure architecture scenarios. But first, some good news. Having successfully managed costs, user permissions, virtual machine or VM performance, and resource optimization, you have been promoted to Cloud Solution Architect. This exciting new role involves designing robust and scalable cloud architectures to support the company's growing needs. The company's web application is experiencing increasing traffic, and you are anticipating further growth. To ensure seamless performance and user experience, you must design a scalable architecture that can efficiently handle high traffic and peak usage times. This involves implementing strategies for load balancing, auto-scaling, and ensuring high availability. You will leverage Azure's services and best practices to create an architecture that meets the current demands and is prepared for this expected future growth. Let's once again examine the goal, context, expectations, and source to help construct a prompt based on the information you gather. Your goal is to design a scalable architecture for a high-traffic web application. This architecture should also be capable of dynamically adjusting resources to handle varying levels of traffic, ensuring that the application remains responsive and available during peak usage times. The architecture should also incorporate best practices for resilience and fault tolerance. Let's build on your prompt with some context. What's the situation? The company's web application is experiencing increasing traffic, and you anticipate further growth. To accommodate this, you need to plan for high traffic and peak usage times by designing an architecture that can scale seamlessly. This involves understanding current traffic patterns, predicting future growth, and ensuring that the infrastructure can handle sudden spikes in demand without compromising performance. So what are your expectations? You hope to find detailed steps to design a scalable architecture, including load balancing, involves strategies to distribute incoming traffic across multiple servers to prevent any single server from becoming a bottleneck. Next is auto-scaling. You will need mechanisms to automatically add or remove resources based on current demand to optimize performance and cost. Another priority is high availability. You must ensure that the application remains operational and accessible even in the event of server failures or maintenance activities. And finally, there's fault tolerance. You seek methods to design systems that can continue to operate correctly even when some of their components fail. Now that you know the expectations, next is the source. Where should you look for this information? You should refer to the Azure Architecture Center documentation for accurate and detailed guidance. This resource provides best practices, design patterns, and guidelines for building scalable and resilient cloud applications on Azure. Using the goal, context, expectations, and source, you can now construct the following example prompt: how to design a scalable architecture for a high-traffic web application in Azure. Provide steps including load balancing and auto-scaling. Reference Azure Architecture Center documentation. Now let's review what Bing Copilot generates from that detailed and informed prompt. As you can see, it has provided detailed steps on load balancing, auto-scaling, resource partitioning, high availability, caching, and content delivery, database considerations, security and identity, and monitoring and alerts. At the end of the output, you'll notice it has provided additional reference material to deepen your understanding. It's time to take this content and put it into action. Let's start by using Bing Copilot to create a comprehensive Azure architectural document. In the Ask Me Anything box next to New Topic, type, "Help me create an Azure architectural document based on the above information. As you can see, Bing Copilot has generated an Azure architectural design document for a high-traffic web application. So what's next? Now that you have your architectural document, the next step is to develop a detailed project plan. Again, in the Ask Me Anything box next to New Topic, type, "Help me create a project plan document based on the above information." Well, that was fast. But what if you need more? You can further refine and expand your project plan by asking Bing Copilot to add specific tasks for each milestone. So there you have it. You now have all the information needed to get started on your Azure architectural journey. In this video, you have gained an understanding of how you can embark on your architectural journey with these resources at your fingertips. It's time for you to take the initiative and leverage these strategies to design and deploy scalable, resilient Azure architectures. Basic scripting and automation is a valuable skill for streamlining Azure management. With Copilot's code completion and suggestion features, you can now automate these repetitive Azure management tasks. In this video, you'll dive into the technical aspects and explore several key topics from the Azure Cloud Support course, including crafting effective prompts, leveraging actionable insights, and identifying quick wins for continuous improvement. Let's start by examining how to craft effective prompts using Copilot to generate and refine scripts for automating common Azure management tasks. When you work as a cloud support engineer, you'll need to deploy a standardized set of Azure resources consistently across different environments. This includes virtual networks, subnets, and virtual machines, or VMs. And you aim to automate this deployment process for improved efficiency and reliability. You're responsible for ensuring consistency across development, staging, and production environments by deploying Azure resources using automation. This approach streamlines the deployment process and reduces the risk of configuration errors or inconsistencies between environments. You must design and implement automation workflows to deploy Azure resources using Azure Resource Manager, or ARM templates. This involves creating templates that define the infrastructure configuration and then deploy them across different environments to maintain consistency. Let's examine the goal, context, expectations, and source. Starting with the goal, what do you want to achieve? You want to deploy Azure resources using an ARM template to ensure consistency and reliability across development, staging, and production environments. Next, the context. What's the situation? You need to ensure consistency across different environments by automating the deployment of Azure resources. This includes virtual networks, subnets, and VMs, and the goal is to streamline the deployment process and reduce the risk of configuration errors. So what are your expectations? What do you hope to find? You hope to find detailed steps for creating an ARM template that includes virtual networks, subnets, and virtual machines. These steps should guide you through the process of defining the infrastructure, configuration, and deploying it across multiple environments. And finally, the source. Where should you look for this information? You should refer to the Azure Resource Manager documentation for comprehensive guidance on creating and deploying ARM templates for Azure Resource Management using the goal, context, expectations, and source. You can now construct the following example prompt. How to create an ARM template to deploy a virtual network with 2 subnets and a virtual machine in Azure. Provide detailed steps and reference Azure Resource Manager documentation. Copilot has provided detailed steps to complete your task. For your next task, you have to ensure data protection for Azure VMs by automating the backup process. This involves scheduling nightly backups to safeguard critical data and streamline the restoration process in case of any unforeseen incidents. To successfully carry out this task, You must design and implement PowerShell scripts to automate the backup and restoration of Azure VMs. These scripts will ensure data protection and business continuity for the organization. Let's examine your goal, context, expectations, and source. For the goal, what do you want to achieve? You want to automate the backup and restoration of Azure VMs using PowerShell scripts to ensure data protection and business continuity. Then, the context. What's the situation? You need to schedule nightly backups of Azure VMs to safeguard critical data and streamline the restoration process in case of any incidents or data loss. And what are your expectations? What do you hope to find? You hope to find detailed steps for writing PowerShell scripts to automate VM backups and restoration. These scripts should include instructions for scheduling nightly backups and implementing a seamless restoration process. And lastly, there's the source. Where should you search for this information? You should refer to the Azure Backup documentation for comprehensive guidance on automating VM backups and restoration using PowerShell scripts. To create PowerShell scripts, you will need to use two prompts. Using the goal, context, expectations, and source, you can construct the first prompt as follows. How to write an Azure PowerShell script to automate the backup of an Azure virtual machine every night at midnight. Include steps for restoration and reference Azure Backup documentation. Once again, Copilot has provided detailed steps to complete the process. Now to create the PowerShell script. In the Ask Me Anything box next to New Topic, type the second prompt as follows. Create a PowerShell script, PS1, using the details from the above output. Copilot generates the output as shown on screen. You can now copy the output to Notepad and save it. Remember, it's important to test your auto-generated script before executing it on production to avoid any unintended results. While managing cloud environments, you often encounter PowerShell commands and scripts. Understanding these components is essential for executing your tasks efficiently and ensuring the smooth operation of cloud infrastructure. You can even use Copilot to provide you with explanations of what these commands and scripts do. For example, give me a detailed explanation on what the below command does. Remove -item, space, -path, space, :/temp, /files, space, -recurse. Copilot instantly generates the output, providing you with the answer you need. Similarly, for a PowerShell script, you can enter a prompt like, give me a detailed explanation on what the below script does, and insert your script content. Copilot then generates output to break down your script step by step. In this video, you explored the powerful capabilities of Copilot for automating Azure management tasks through scripting. You examined various scenarios, from deploying Azure resources to automating backup and restoration processes using PowerShell scripts. By leveraging Bing Copilot's code completion and suggestion features, you can streamline repetitive tasks, enhance efficiency, and ensure the smooth operation of Azure environments.
Congratulations on reaching the end of the Microsoft Cloud Support Associate Professional Certificate Program. This means you have not only completed all courses, but you've increased your expertise in cloud computing. By getting to this point, you've enhanced your understanding of various Azure products and services and the roles they play when it comes to configuring, connecting, securing, and monitoring cloud-based environments and the resources that they house. But that's not all. Completing this program also means that you've covered the main topics represented in the Microsoft Certified AZ900 exam, Microsoft Azure Fundamentals. You tested your knowledge by completing a series of assessments mapped to these topics, which has you in a better position to succeed in the proctored exam. Now that you've completed this program, you're ready to take the next step and schedule the AZ900 exam through Pearson VUE. However, before you do so, let's recap what exactly you gained during your journey. Through a mix of videos, readings, and practical exercises, you learned about the fundamentals of cloud computing, including key concepts, benefits, and different models, along with an introduction to core Azure services and their applications. You then followed with a comprehensive overview of Azure Cloud Services, which covered everything from resource configuration tools to solutions for bolstering security. Moving on, you unpacked Microsoft Entra ID and its role in identity and access management in Azure environments. You also became familiar with tools and strategies for creating and managing virtual networks and provisioning resources. Next, you took a deep dive into Azure network configuration and picked up skills for load balancing, storage management, and network security. Your journey then continued with an exploration of Azure Monitor, a tool for tracking resource health and performance that also facilitates proactive action. You then learned about Azure Log Analytics as a solution for extracting trends, patterns, and other insights from logs. And finally, you developed your understanding of Azure Backup strategies, security protocols, and considerations for compliance administration. By completing this program, you'll acquire the Microsoft Cloud Support Associate Professional Certificate. This certificate not only lays the groundwork for a career as a Cloud Support Associate, but it also serves as proof of your job readiness and can be shared with your professional network. To validate everything you learned, you completed a mock exam that follows a similar format and set of standards as the industry-recognized AZ900 exam. Recall that this exam measures your ability to describe the following: cloud concepts, Azure architecture and services, and Azure management and governance. Upon successful completion of the AZ900 exam, you can share your certification, which greatly enhances your IT portfolio. Furthermore, this certification serves as evidence to potential employers of your motivation to enhance your knowledge and skill set, your perseverance for taking on challenges and seeing them through, and your willingness to adapt and try new things. Your journey of discovery has required a great deal of dedication, and you should take pride in how far you have come. Completing all of the courses in this program was no small feat, and your achievement should be recognized. As you prepare for the exam, remember that the learning material in this program is available to you for review as needed. It has been a pleasure to accompany you on this road toward growth and discovery. Best of luck with the next part of your journey.